Hi, we're going to start from 1:05. We are waiting for more people to come.
Imagine being able to build an app with your name on it just by thinking about it. Meet Base 44, a complete AI creation platform.
All right, so let's get started. 皆さん、こんにちは。今日はありがとうございます。Those who joined online, thank you very much for coming. First of all, some announcement from Medai University. First, 学内禁煙お願いします。はい、禁煙はキャンバスの中、あるいは真ん中の山手通りも含めてできないので、すみません、ご了承ください。あと2つ目、Wi-Fi、ちょっと名古屋大学のルールもありまして、ちょっと皆様にご提供できないので、申し訳ないですけど、6、7時間、ちょっと集中して、プレゼンテーション聞いていただけるとありがたいです。あと最後に、出口のところにコーヒーとかお水とか、あと、少しお菓子も用意してますので、ぜひ合間とか、あとブレイクの時とかにぜひ取っていただけるといいかなと思います。はい。というアナウンスメントはこれまでにして。Alright, so my name is Daisuke Tanaka. I'm president of the Autoware Foundation. Once again, thank you very much for joining us celebrating 10th anniversary of the Autoware. And the Autoware was actually invented here in Nagoya University back in 2015. So now 10 years has passed since we started this journey. So today we have a bunch of very exciting presentation from Autoware Foundation members, as well as the Autoware lovers across the globe. So first, I will do a kickoff. Again, this is the very first AutowareCon, the Autoware conference. We plan to, actually, we had a plan to celebrate this 10th anniversary more than half a year ago. And we chose this place at Nagoya because this is exactly where the Autoware was born. So Autoware is still in a very early stage, even though it's 10 years have passed. So more to come. And we have many exciting news from Zane, from Mitsume-san for the upcoming development effort we're going to make as Auto Foundation and also as a community of Autoware. So today's agenda, so I'll do kickoff right now, followed by the sharing of the highlights of working group by Mitsume-san. Then we have 10 plus presentations from Autoware members. Then we have very exciting roadmap presentation by Zane. Then we have break around 4 o'clock. Then Shinpei, who is the father of the Autoware, will come here to make a key presentation. Then we have the online presentation from Steve Taylor in the UK, who is going to make a presentation or updates around the Autoware Foundation organization changes that we made, which is Autoware Foundation 2.0. Then we're going to share some development stories from members. Then after 6 o'clock, we will be to the different buildings in the campus and have a networking event with alcohol drinks and buffet. So hope everyone can join us until 8 o'clock today. It's going to be a very exciting 7 hours. So please make a full focus on what we're going to share going forward. All right, next page, please. So here is the update from the member companies. So we started from 18 companies in 2018. So sorry, some messy in text, but then now we have more than 100 official member companies joining in the Autoware Foundation. Some are from academia, and the others are from industry. But we believe that this is one of the largest open source network or community in the world. And we are growing, and month by month, we invite 3 to 5 new member companies from across the globe. Next. So I would give you some history that we have made in the past decade. First, we launched the Autoware Foundation, which is the not-for-profit organization, Ippanshara Houjin in Japanese, or NPO, who manage the development environment, including GitHub, and also promote Autoware to the industry and the community. Then we started the COE effort, COE Journey, Center of Excellence, the collection of universities who love Autoware. And as of today, this is one of the largest academic network for automatic driving. Then we started regional hub attempt. So we started from Taiwan 2 or 3 years ago. Then we are pushing US, China, and some others. So these regional hub will play the local hub in that region to bridge the communication in academia industry in the region, and also have a smooth communication with headquarters in Japan and locally. Then in terms of GitHub popularity, we have achieved 10K starts on GitHub. Congratulations, everyone. But this is just the first step. So we need to aspire 20K or even 100K in the coming years. Then finally, we see many real-world deployment out there. In autonomy, for example, or Tier 4, or Optech in Estonia, Bixmove in China, and many others are doing POCs or actual operations in each region. And you want to listen to some stories at 6 o'clock, or sorry, 5 o'clock today. Then going forward, we need to make Autoware more known, more popular. So the Autoware Foundation is now pushing the initiative called Fix the Front Door. Basically, we want to improve the awareness and recognition of the open source solution in the AD arena. Then we also are working hard to expand our ODD coverage. Not only the shuttle bus or robotaxi, but we plan to start trucking working group, for example, off-road, mining, agriculture. But this is not the effort that only the Autoware Foundation member can do. We need your help, member companies, active participation. So if you want to push a new ODD, let us know. Then we're happy to launch new working group or form a team in the Autoware Foundation or Autoware community. Then E2E AI, it's kind of popular. It's lots of robotaxis running E2E AI in the US, China, UK. But Autoware Foundation will also push this effort. Then we present what we're going to do going forward. Then academia collaboration. So we have a COE, but there are lots of room to improve. More cross communication, more collaboration, more sharing. So Autoware Foundation is now making a new effort to upgrade the COE network so that it's visible, transparent, and more effective to everyone. Then finally, standardization or safety protocols. There are lots of discussion happening in a global scale. WP29, for example, or World Economic Forum, there's a bunch of discussions for standardization or safety initiatives. So Autoware Foundation also want to make an important role in this effort. And we are thinking of starting a new initiative, either working group or new task force, but we want to start a new journey on this front. So today, you listen to some of the initiatives that we are planning. And I hope that you have a very active participation, raise questions, exchange ideas in this conference. Right, that's it from me as kickoff. Then I'll hand it over to Ms. Some-san for the working group discussion. Thank you.
Okay, hello everyone. So nice to meet you. I think most of you already know me, but I'm Ryosuke Mitsudome, and I currently kind of have a role in the Autoware Foundation as the chair of technical steering committee, where we drive all the technical activities and projects in Autoware Foundation. So today I will just give you the updates about what we're doing in the Autoware Foundation working groups and how we organize it. I don't think we'll have like enough time to explain so much detail, so I will just keep the highlights quite brief. But if you are interested in any of the items that I'm going to share today, you are always welcome to join any of our working group meetings. They're always open, and yeah, you can just join anytime from our Autoware Foundation calendar. So let's move on to the slide. Yeah, you can please move on. Okay, so just a recap. So this year, as kind of Autoware Foundation's executive leadership team and the board and TSC and SPC, they've been kind of starting to define the vision, mission, and core values of the Autoware Foundation. And as you can see, the vision is to build open source software for a globally trusted autonomous driving system that engage an advanced society. And for the mission, we said co-create a neutral, trusted hub that advances safety and beyond in mobility and society. And to support this, we also defined core values: open source, collaborative, deployment ready, and cutting edge. So today, I will kind of mainly focus on this deployment ready and cutting edge part of the core values, which we use this as a kind of a keyword to start defining our objectives and execution roadmap of each working groups. Move on. So a bit more detail about the objectives. For each keywords, we've kind of defined these three key objectives for technology to define our roadmap. The first one is to incorporate cutting edge technologies like E2E AIs in Autoware software as part of an AI-first approach. We also want to develop Autoware software towards production ready, not just for research, but for production solution that can be more easily commercialized by the member companies or organizations. And increase deployment of Autoware software to a greater number of vehicles, driving more miles autonomously. So these are like key goals that we kind of defined for technology. And from those objectives, we started to kind of define these multi-year roadmaps. As the first year, we've kind of stated to introduce a component-based AI stack for perception using key autonomous driving sensors, and also develop an initial version of AI-based planner to enable a full E2E AI component-based autonomous driving stack. I think these kind of architecture will be more explained in detail in Zane's presentation later. So I'm not going to go into the detail in my presentation, but these are basically the goals that we set. Even there. Okay. So yes, and so for the production ready, we want to make sure that we create a first version of production capable Autoware, which will be kind of deployed to the actual environment with our anchoring company as well. So these were kind of goals that we set. And next page. Yep. And yes, so for restructuring, so once we define the objectives, we started to kind of basically define what we'll be working on in each of the working groups that we have in the foundation. So here are the list of the working groups that we have today. So at the top, we kind of list up all the kind of supported use cases that we would like to cover in the Auto Foundation. Like Daisuke-san mentioned earlier, we would like to increase these use cases as long as there are more interest from the foundation members as well. But for now, we have these working groups to kind of define our reference designs for the community or like the users Autoware to basically reference to define their own kind of system using the open source software. And yeah, that's this. And yeah, and we have basically all the other working groups to support, develop like the supporting technologies to achieve that use cases. And yeah, and I just want to kind of mention that we are actually planning to create another working group. So this is Trucks working group proposal that was kind of made in the previous TSC last month. And we actually had a meeting just right before this conference, and we've kind of decided to start this working group on October 10th, and led by these kind of member companies on the right. So once we start, if you're interested in trucks using Autoware, then please join and help us out with defining the reference design and developing Autoware for trucks. Yes, so now that we structured the working groups, we actually also started to define more details of our key milestones. So these are going to be available in the Autoware documentation. The visions and core values, they're also kind of made public on the Autoware documentation. You will notice there's a roadmap tab in the Autoware documentation website. We're not quite there yet to fill out all the details. Copying from our internal documents, but I think it will be kind of pretty much fully complete sooner or later. So yeah, basically for each working groups, we've defined these quarterly milestone goals, and then also breaking down into monthly kind of action items as well to make sure that we keep track on what we do on each of the working groups. So yeah, I don't think we have time to kind of explain the details, but yeah, I just want to say that we have these all the planned activities for each working group according to our roadmap, so that we know that we'll be able to achieve what we stated in our objectives by next 3 years. Please. And yeah, so now that we have action items to be listed up, we also started to track our kind of resources for each working group members. So we actually have this bi-weekly meetings amongst the working group leads to check if each working groups have enough kind of resources. So basically the members, hardware or any other software license and so on, to make sure that we have enough kind of resources and no blockers to execute the roadmap. Obviously, if there are any kind of insufficiency, we kind of ask to the members or kind of coordinate with SPC, the Strategic Planning Committee, to check to basically announce or call for kind of participation publicly to see if we can kind of suffice any missing engineering resources for our activities. But yeah, for at least for now, so we're actually at the phase 2 of a roadmap, and at least until September, we've actually confirmed that we actually have enough members to execute action items in the working groups, but we still have some concerns about upcoming phases. So like I said, we're always welcome with and yeah, welcome with help. So yeah, I think if you join and make sure that we have all these boxes in green, that would be nice. And yeah, we also alongside with this kind of roadmap task force, we also have architecture task force that defining about overall kind of architecture design. So which will affect and reflected to each working group activities. But this one, like I said, this will be kind of explained in Zane's session, I believe. So please kind of be excited to kind of hear his presentation later. So yeah, those were the kind of high level explanation of what we've kind of been organizing, how the working groups should collaborate each other. So for the next slides, I just want to kind of show some of like the recent activities that we've been working on in each kind of working groups. So I'm not gonna, I don't think we have enough time to explain every working groups, but I just picked up some of the interesting topics that was sharing the last couple TSC meetings, so that you know what our kind of recent interest of each working group activities are. So first is a privately owned vehicle working group. So as you can see from the name of the working group, they're mainly focused on creating E2E foundational models for privately owned vehicles. We have these neural networks designed to have a backbone to extract features, and which will be passed down to different heads to basically do the inference for each different kind of objectives of the network. So for example, detecting lanes, detecting like free space, detecting like the foreground objects, detecting like depth or distance to the object and so on, which will be then kind of merged back into together in as a planner to kind of execute it as a Autoware kind of control behavior. Slightly. And yeah, so originally we've been kind of up till now we've been like developing this neural network models as kind of isolated repository and as isolated software. But now we have that trained model to be wrapped around as a ROS node package. So it's almost ready to be connected with the rest of the Autoware stack and also to test with the Carla simulators to actually do the simulation testing with the Autoware. So yeah, as you can see, if you're familiar with ROS, you notice that these coordinates at the base, and this left image shows like the detected image of the lanes showing with these red lines. Next slide, please. And yeah, moving on to the software working group. Okay, we don't have the permission, but let me just explain. So I just had we just had a ROSCON event yesterday, ROSCON JP. And the event, I actually kind of gave a presentation about our first release of Autoware Core, which is released as a binary package from ROS Build Farm. So you can now install the core functions of Autoware with just a single line apt install command from ROS Build Farm. So I think a lot of you have experience in failing to build Autoware at least once, but now you don't really have to build to just drive in a single lane. For now, if you want to use the full function of Autoware, you still have to build from source. But if you are like the beginner for the Autoware and would like to use the fundamental functions, you don't really have to do that anymore, and you can just install from binary. Next slide, please. Okay, I guess we don't have any access to the image, but anyways, so yes, so there's also activities going on in the software working group to develop all the learn-based modules as well. So I think there was also a presentation coming up from Multicoreware later, but they've been working on updating some of the perception pipeline of the Autoware using camera-based detection of bounding box of surrounding objects. We also have tier 4 working on diffusion planner, which is basically a learned-based planner to be driven from a given kind of information output from perception to do a church key generation. So yeah, the idea is that these will be kind of working as we'll kind of modify the architecture so that we can actually have a smooth transition to these to introduce these technologies so that we don't kind of break any existing architecture as well. Slide, please. And so yeah, and also for the ODD working group and simulation working group, they've been kind of working on to update the simulation pipeline of the Autoware, and this is just part of it. So for example, like the ODD working group, they've been kind of discussing to define like the unified format for defining the scenarios. So ultimately, we've planned to kind of use open scenario file format for now to define the scenario format. But before that, in order to kind of define the use cases in more natural language format, we decided to use Gherkin syntax and basically define what is the actual test that we want to make for each functions of like a reference design that we're working on. And from these natural language written use cases, we will basically write up the open scenario format. Hopefully, if you can use like a LLM or any other kind of AI tools to automate these generations, that'll be great. But for now, we're starting with manual generation. And once that's done, we plan to kind of feed that into our scenario simulator pipeline to be simulated with like other simulators like Carla or Awesome or some of the planning simulators that we have in our community. Slide, please. Okay, great. I guess I forgot to give all the permissions for the videos when I sent my presentation slides, but okay. So for the OpenAD Kit working group, so they're working on mainly on making Autoware easy to deploy to the edge devices and make sure that we have a cloud native development pipeline to have the cycle. So for the recent activities, we've been updating all the Docker Compose files and the Autoware so that we can just launch Autoware in a single line with Docker with multi-container setup, for example. So in the future, if we want to update like the perception pipeline using, for example, like the perception that I've shown in the software working group, people just have to update the perception Docker image with while keeping the other rest of the modules and make sure that they can update the features that they would like to use from the latest version of the Autoware. So they've been working on these generation of containers in a modular way. Next slide, please. And yeah, so for the off-road working group, they've been kind of working on also closely with simulation working group. They're still at the very early stage about kind of collection of the data sets and also about creation of the simulation environment. So for the target scope of off-road working group, they have like different environments, but one of them is lunar environment, like you see in the left. So they've been kind of creating these simulation environment. So this is actually the 3D environment that they've generated for lunar space. But obviously, for most of the people on Earth, they're more interested in close areas as well. So we also have targets about mining regions as well. So for that, we've started to collect these open data sets available for mining use cases so that we can actually use this to train our models and apply to the environments where we don't really have like structured lanes. Yeah, so those were some of the highlights of the working group activities. Like I said, I wasn't able to share all the activities that we've been doing. I think Samit from the Auto Foundation, he's also started to send out the TSC newsletters as well. So if you subscribe to it, you can always get the monthly reports of the working group activities as well. If you're too busy to join to the working group meetings, that's also an option to keep up to date. And you can always, like I said, join our working groups or Discord to get on hold. If you have any further questions, you can just ping me on Discord and ask questions, or you can just talk to me in the networking event today later. So yeah, that's pretty much the presentation for my slides today. So thank you everyone for listening.
So good morning and good afternoon, everybody. My name is Mohammed Zain Khwaja. I'm the Managing Director of Product at Autoware Foundation. And today it's my pleasure to be the moderator for the upcoming community contributions section, where we have invited members of the Autoware community to give lightning presentations, around 12 minutes for their technical discussions, and around 3 minutes for Q&A, highlighting some of the great work done in the open source domain in developing the Autoware project. So with that, it's my pleasure to invite the first speaker in this technical track, which is Tran Hu. So welcome up to the stage, Tran. Can we have a round of applause for Tran, please? Thank you. There you go.
Thank you, sir. So we start. All right, so hello everyone. So ladies and gentlemen, to the people here in person and in the Zoom meeting. So I'm honored to be here, and my name is Chon Nhật Huy, currently a student, second year master's student at Tokyo Institute of Technology. And today I'm really excited to present AutoSteer, an end-to-end path prediction project, which is developed under the supervision of Mr. Mohammed Zain Khwaja. He's sitting right there. And we're here today at Autoware 2025 Con in order to discuss the end-to-end future of autonomy. I believe it's going to be a really interesting project to talk about. So next slide, please. Thank you so much. And today we're going to walk through the introduction, where we introduce about this idea and the methodology, a brief introduction of the model architecture, and so on, and some very early experiments and results, as well as some discussion. Next slide, please. So now let's go to the introduction, the end-to-end path prediction, and the background motivation. Next slide, please. So regarding this, the context of this project is the Autoware privately owned vehicle, and here we try, like, our goal here is kind of ambitious. We are trying to like make a mapless SAE level 4 approach on primarily focus on the high risk scenarios, and this approach kind of shift the fundamental questions of autonomous driving from where is it safe? No, sorry, from where are we on the map to the more human-centric question, where is it safe to drive? And so basically we're trying to, this also introduce a critical challenge. Basically the driving corridor, we need to recognize the driving corridor accurately, especially under some scenarios like unclear lane markings or adverse environments and the dynamic unstructured elements like a construction sites and so on. Next slide, please. And this motivates us to introduce to you the AutoSteer project, which is a single unified network that can holistically perceive driving corridors from multi-camera inputs. And from multi-camera input through a set of like components like BEP transform, backbone and feature structure, and so on, we can output a single channel segmentation mask of the drivable corridor. And from here, we can also infer the lanes and the road edges, which serves our objective. Next slide, please. All right, so next we go to the methodology, which is the model architecture, dataset, and so on. Yes, okay, thank you. So for the system architecture, so our model architecture, as you can see here, follow this architecture. So basically, we designed the model as a unit-like architecture, which is primarily for segmentation mask. As you can see from the multi-camera input, it will go and enter the BEP transform first in order to like transform the scene and the ground truth lane annotations. And then we have a encoder-decoder based approach where we have the encoder in the encoder, we have the backbone feature structure and the BEP feature fusion. And we also have the BEP path context as a middleware between the two. And for the decoder, we have the BEP path next and AutoSteer head, which will serve as upsampling features while re-injecting the high-res details via the skip connections. And the output will be a single channel segmentation mask of the drivable corridor. So firstly, let's talk about the dataset. In order to train a robust model, we need to have a diverse dataset. So with the help of the other POV working group contributors, we were able to like gather and process a lot of open source datasets, particularly TuSimple, CU lane, curve lanes, B200K, we come out 2K19, roadworks, and very recently the open lane. So we tried a lot of these data sets, and in the end, for the current version, we focus on the TuSimple, curve lanes, and open lanes being used for the training the model. Next slide, please. So firstly, for the BEV transform, we currently try to transform the original perspective into the BAV or bird's eye view perspective using a homographic matrix, which is a very classic approach. We try to map 4 source points from the perspective view into the 4 fixed destination points that defines a rectangle in the BEV views. So as you can see, we have a lot of data sets, and they are either, the camera pose of them are either fixed or varied. So we're kind of like following a very hybrid approach of using either fixed transformation matrix or per frame transformation matrix in order to compute the homographic matrix and to do the BEV transform accordingly. Next slide, please. For example, this is a too simple scene, which we will use the fixed transformation approach because like the camera pose of the too simple is really stable. So we kind of go with the fixed transformation approach in which we will select a standard frame and from there compute its standard source point, and then we apply the same source point and the homographic matrix in all other scenes. And the next slide, please. The next slide is curve length per frame approach. So in curve length, we have very diverse camera pose and camera intrinsics on each frame. So for each frame, we're trying to calculate the 4 source points dynamically via the length annotations, as you can see. And then from that, we will calculate the homographic matrix, and then we will do the BEV transformation. Next slide, please. And then we'll go for the model architecture. So because we don't have a lot of time here, so I will just go through it quick. So in the encoder, it will serve as the feature extraction and diffusion. So for the backbone feature extractor, we will use a pre-trained efficient dat B0, and this will process the input image and then outputs a feature parameter, a multi-scale feature parameter map of the 5 tensors, and which will capture both low and high level semantics. And then we go through the BEV feature fusion, in which we will fuse all of those maps into a unified BEV feature map. Next slide, please. And we also have the component called BEV path context, which acts like a middleware between the encoder and decoder. It will refine the BEV feature map with a contextual reasoning used in an element-wise attention using the MLP branch and a context branch. Next slide, please. And finally, the decoder, it will combine of the neck and the head of the AutoSteer. And in the BEV path neck, we will try to upsample partial resolutions of the feature maps, and then we inject the high and low level spatial details from backbone encoder via connection. So for the AutoSteer head, we will try to take the net tensor, the output of the previous component, and then complete the upsampling. And the output will be a final BEV segmentation mask. Next slide, please. So now we'll go to some experiments and the results. So as you can see for the data set, as previously mentioned, we will use the primarily three data sets of too simple, process data set of too simple, curve length, and open lane. So in total, we have around 150K of trained samples and 15K of val samples. And next slide, please. And for the training strategy, as I previously mentioned, the AutoSteer head will output a single channel output map. And this is basically the segmentation map of the drivable corridor. And in order to improve this segmentation mask, we will imply the training loss will be the sum of the segmentation loss and the edge loss. The segmentation loss is a binary cross entropy loss which is the between the prediction mask and the ground truth mask. This will help the model trying to learn the shape of the drivable corridor. The second training loss is the edge loss, which is basic. That's which is basically a sum of the multi-scale loss between the multi-scale loss between our feature, between the feature map, between the pred and the ground truth. And this loss is to ensure that we have a sharp boundary in the drivable corridor mask. And thank you. And here's some results. So for the too simple is a data set comprising of various US highway scenes, which in various conditions in terms of weather, highway traffic, and so on. Next slide, please. And as you can see, so the first we can see that the prediction kind of matches the ground truth in these scenarios. Next slide, please. As well as the scenario with the presence of the other vehicles. Next slide, please. And the scenarios where the drivable corridor being curved in the far end of the road. And then we have the curve length. So basically, the curve length features the various scenes in the urban and highway scenarios in cities across China. And this dataset also features primarily a lot of curve and multi-lane scenes, and so as well as the varied conditions and especially the camera pose. So, the slide please. So as you can see, this was again the model can fairly accurately predict the drivable corridor in terms of shape and in terms of like the boundaries. Next slide, please. And this also applies during the tunnel scenarios, and as well as the like nighttime with some kind of like light variance, ambient light variance. And finally, we have open lanes, which is like featuring highway and urban roads somewhere with a very varied condition as well. And next slide, please. As you can see, it also correctly predicts in terms of like drivable corridor shape and lane boundary and the shape boundary. Sorry, across multiple scenarios. Next slide, please. Thank you so much. And we have some final discussions as well as, so we have some key insights. Basically, as you can see, our current version of the model actually outputs some fairly good accuracy across the diverse scenarios. And it can identify drivable corridors in curved lanes and tunnels. At the same time, it also effectively do some web transformation and segmentation. And it can learn to transform features from behavior and perspective. And it usually match the geometric layout of the street. And finally, the robust end-to-end learning without relying on various rule-based detectors, the model can learn a robust and holistic understanding of the drivable corridor. So, and of course, you can see this is not yet the final version of the model, and because like the current segmentation results are still not really perfect. So in some scenes, in a lot of scenes, you can still see some blurry edges and sometimes even some weird artifacts, which implies some more effort onto training the segmentation model. So, and also like we have some limited computational resource. Currently, a lot of this model is primarily trained on my workstation desktop. So I think like this will also limit the effort of fine tuning. So the next step, we will try to continue the training and adding more data if needed, and as fine tuning the parameters. And if possible, we will also consider qualitative benchmarking in the near future. So yeah, finally, this is, so in order to wrap up this meeting, this is a slide that is a clumsy attempt to add some emotional wrap up. I think it failed anyway. So yeah, so this is the kind of like a Quran verse cited by Mr. Zhang a while ago. So basically, indeed after hardship, there's ease. And actually while training this model and developing this model, we come up with a lot of like challenges. But I believe that in the end, we will be able to finish this model, and it will be a really great addition to our current end-to-end approach. And that's the end of my presentation. Thank you so much for your attention. And if you need it, there's a QR code for accessing the slides. Thank you so much. Yeah.
Thank you very much, John. Does anybody have any questions from the audience or from Zoom?
Okay, thank you.
I'll bring the mic to you. This one? Is it on?
Thanks. Right. Okay. Very quickly. You have a large collection of data sets. That's great. A lot of things. Some of the data sets, if you go like 4 slides back, some of the ground truths seem to be truncated due to the presence of obstacles, for example. So I wondered, like, for example, that one has a vehicle. So I wonder, for example, where that vehicle is not present, where in your training set you have evidence that the lane stops where the obstacle is was present in the training set.
Oh, thank you so much for your question, sir. So basically, as far as I understand, you're asking if the obstacle, if like the obstacles, for example, like other cars really affect the ground truth, right? So apparently, currently we kind of like create and process the ground truth based on the lane annotations of the dataset, because like all of the dataset here are the lane detection dataset benchmark. So basically, with that being in mind, I don't think that like some of the dataset will take into account the kind of like other obstacles. But apparently, I believe that like most of the datasets and most of the data samples in the current training does not really take into account the other obstacles. Yeah, thank you.
Great. I think in the interest of time, we'll go to the next presentation. So thank you very much for the presentation, John. So our next speaker is from Multicoreware, Selvantiran Rengaraj, who I believe is joining online. Yep, he's over there. So I'll pass over to you. Thank you.
Thank you. Thank you for the introduction. Let me share my screen. Okay. Good afternoon, everyone. Hope my screen is visible and I'm audible. Good afternoon, everyone. So I'm going to talk about the work we did on BEV integration to Autoware perception stack. Very quick introduction. So I'm from a company called Multicoreware. I'm a solution architect here. I've been with the Multicoreware for around 4 to 5 years now. I mostly work with software optimization for ADAS and IVI perception stack. So Multicoreware is a software solution services-based company headquartered in the San Jose. We work with companies like tier ones and OEMs for both ADAS and IVI and automotive semiconductor platforms, as well as SoC companies and semiconductor platforms for high performance software optimization. We partnered with Autoware in December 2024 to integrate BEV bird's eye view based perception models to the Autoware universe and Autoware core pipeline. So we also have a team like Abhishek from the US, who is part of the strategic planning committee of the Autoware Foundation, as well as Milan Patel from UK, who is a technical steering committee of Autoware Foundation. And I also listed some of the engineering team from Multicoreware who's contributed to this open source collaborative effort. So before I talk about the work we did, I wanted to give a brief introduction about the brief overview of the Autoware perception stack, so that you will get an idea of where our contribution is going to make an impact. Some components I've highlighted here, starting from sensor data. The Autoware perception stack work with different sensors, as you know, like camera, LiDAR, radar, IMU, all sort of different sort of camera. And once you have the raw data from the camera, we do pre-processing, or you call it as data conditioning, where you have to calibrate this data, and you also need to make sure all the data from different sensors are synchronized, and you have to do some filters, noise removal, and etc. And then once you have your data that is calibrated and synchronized, you pass it to recognition, wherein it for image based, it can be object classification, segmentation, detection, etc. And for LiDAR, it can be 3D object detection, etc. So each camera modules will have different recognition pipeline. And once you have that, we'll combine those algorithms. For example, your camera will be giving you 2D detection output, and then LiDAR will be giving you 3D detection output to sort of bring it to the planning, and then whole full pipeline. You have to fuse all this outputs from different sensors to get a unified view. So that is the fusion approach. And then once you have the fusion, you also need to do some tracking. You want to track the dynamic objects over time. And then you also do localization. You want to identify the position of the vehicle in the given environment, etc. Once we have all this, we will pass this information to the planning pipeline as well as the control to drive the vehicle and take actions and etc. based on all this information. So the role of BEV models in pipeline in the perception pipeline is that let's say we are going to approach that is is going to work with a different modality. For example, there are PV models which operates with different modalities. It can be camera, it can be camera plus LiDAR, it can be camera plus radar, or combining all three. So it eliminates, having different pipeline for different modalities. So it gives a unified view, and but the one single model can take care of the entire process, all the way from sensor calibration to your object detection, and then you can directly pass it to our planning. And it is, since it considers the different modality of input. For example, even if you just take camera, it is going to consider 4 to 6 cameras at a given time. So it is the quality of output that we are going to get from this BEV based approach is very effective, and so it can be used for advanced decision making. So I'll talk about how the results will look like and etc. in the next slides. So if you see here, this is how typical bird's eye view approach looks like. So here it uses only 4 camera, but it can also be 4 or 6, or the number of cameras can vary, and the position it mostly be 2 cameras fitted at the front and back, and 2 cameras at the side, both sides of the vehicle. It can also be 6 as I mentioned. So combining these 4, we are getting an aerial view, or a top-down view of the holistic environment, and considering all the 4 cameras. And so there are different modalities. If you take about only camera, will only operate with different cameras. It can be 4 or 6, and there are different approaches called LSS, geometric based approaches, and then transformer based approaches called image view transformation, etc. So there are different methods people do it to convert this perspective view to bird's eye view. And in terms of LiDAR, people only use the 3D LiDAR point clouds from the LiDAR and then do the BEV. And there are some models already available in open source like Point Pillar, Center Point, which are very popular in the space. And also there are fusion-based approaches where people try to fuse the inputs from 2 modalities, camera, LiDAR, and etc. based on the use cases. So one of the model we consider is BEV Farmer. To explain this, it will take a very long time. I'll just quickly give a overview of what are the novelties of this model and why we chosen it. So there are 2 important features to look at here. One is the temporal feature as well as the spatial feature. For the temporal, the model uses something called as temporal self-attention, where for assume you are operating on 6 camera at a given time. For one single camera, it will try to take the data from the current timestamp as well as the previous timestamp. So the temporal self-attention will try to process the temporal data across the history of time frames to get a better understanding of the scene. And in terms of spatial information, there is a component called spatial cross-attention. So which at a given time, it will try to process all 6 images at a given time. So that is the spatial cross-attention, meaning it will have access to all these 6 images at a given time. So fusing these 2, because it has access to both spatial information as well as the temporal information, it is the quality of output that we are going to get from this model is very effective, and it is also not very computationally very intensive. So to summarize our contribution, we integrated 2 models into Autoware Perception. The BEV DET is already integrated, the PR is already been merged, and we have given support for both FP32 and then FP16, and then FP16 is currently running around close to 35 FPS, which is very useful for real-time scenarios and etc. So because it is highly optimized already, and people can start using it. For BEV Farmer, there are no open source implementation for C++ and ROS2 based method, which is essential for ROS Autoware integration. So we wrote the BEV Farmer implementation from scratch using C++ from all the way from pre-processing to post-processing, and give ROS2 supports for easy integration to Autoware. And the PR is currently in progress. So I wanted to take take this opportunity to thank Mitsuram-san and Fatik and the other collaborators to for their valuable technical insights and comments. So the PR is currently in progress for this particular model, and we have currently plans to optimize this model further. And we also have visualization support. So if you can see the results here. So this was the slide that Mitsuram-san tried to present in his slide. Unfortunately, not there is some access issue, but this is currently running in the Autoware perception stack. This is the actual result that you can get from the newsyn dataset. The model is currently not fine-tuned for tier 4 dataset or real-time dataset. So this is the result that is coming from the Autoware perception for a newsyn dataset. So this is for just for the presentation. I've seen include only 3 cameras, but the model can operate 4 cameras or 6 cameras, etc., based on user configuration. And the effect is that, as I mentioned, the BEV is going to give us a unified view, meaning that is going to simplify the way we look at the environment, going to give us a holistic view of the environment, and it is going to give an accurate detection. You can see the complex or the occluded space where you have there are object behinds on another, and the model is able to identify this object. And there will be cases where one camera will be able to see the object, then the other camera will not be able to see. Even in those cases, the model will be able to give you the accurate predictions as well, etc. And it is very reliable for fusion. It can be integrated, like you can operate with only camera, or you can operate with only LiDAR, or you can combine camera plus LiDAR. And even if one of the sensor fails, for example, you are operating with 6 camera, and if one of the camera fails, the model will still be able to perform the actions. It's not going to fail. So there is a lot of foolproof in it. And it also can do both detection and segmentation, but right now we have given support only for detection, as it is segmentation model is not open source as of now. So this sort of summarizing the efforts. I've mentioned there are some challenges using the conventional individual approaches. It is we have to use calibration for multiple modalities, and then you have to if you're going for a high dynamic scenes where there'll be a lot of occlusions and a lot of moving objects, so the performance might not be very efficient if you're using with a single modality and then 2D based detection. So going for BEV based 3D object detection is going to eliminate a lot of this risks. And yeah, as I mentioned, BEV data is already running around 15 to 35 FPS, and the Beformer is already integrated. The PR is currently in progress, and we'll plan to optimize it further in the coming days. And the BEV fusion is already there in the Autoware perception, which can operate on multiple modalities that I talked about. So the reason why we want to go to this perception is that it is in compared to the other models like center point and transfusion. In general, the BEV model is capable of delivering high accuracy with a lower compute bottlenecks, and it is very robust, and it can operate very efficiently in the complex real-time scenarios. So the next step is we plan to give integer 8 quantization support for more real-time inference support to improve the latency and then the FPS. So currently it is both of the models are running on FP16. And we also have plans to integrate some of the state-of-the-art methods. So the BEV, the reason we chose Beformer is it is very common in the automotive space, and a lot of people are a lot of tier 1s and OEMs is preferring that model. But it is a couple of years old. There are a lot of state-of-the-art model coming in, especially for aligning with the Autoware's end-to-end perception goal. There are models available to handle even the planning all the way from object detection to planning, all in a single end-to-end based AI model. So we plan to integrate those sort of approaches in the in coming weeks in collaboration with the Autoware team. So very quick on how can MCW contribute to Autoware partners and customers. As I said, the Multicoreware have experience working with OEMs and tier 1s for high performance software optimization. So in both ADAS and as well as the IVA space, so we can help the with shuttles and buses, the productization, or it can be software optimization, and we can work with the different sensors, all the sensor I mentioned, camera, LiDAR, radar, all the way from signal processing to your end-to-end detection pipeline. We can help bring in or integrate the Autoware ecosystem and design embedded solution for it. And then we can also help the partners with edge AI and then high performance software optimization depending on the compute that you are going to use for your product. We have experience working with a variety of SoCs and AI accelerators, specifically for the automotive domains. So very quick intro, about the company. So we started in 2009, headquartered in the San Jose, primarily for writing efficient software for multi-core architectures. So that is why it's called Multicoreware. And we have global presence in US, Europe, India, and China. So we target 4 broad verticals. In the compute, we work with different heterogeneous computing from CPU, GPU, DSP, NPU, and etc. All the way from even for the cloud and data center. And in the media, we work with we are the open source. We are also the major open source contributor for X265 and then X266. In the mobility, it is related to what I talked about already. We work with the sensor companies and then OEMs and tier ones, ADAS and IVA, etc. And we also have focus on the smart city, smart health, and Industry 4.0 use cases. So these are some of our partners and customers for your reference. So that's it I have for today. I'm happy to take questions if there are any.
Thank you very much, Selventeran. Very good to learn so much about Multicoreware and the work you're doing. Are there any questions in the room or on Zoom? If not, I have a question for you. So what kind of quantization framework do you think will work well for these types of models? Do you plan to go to ONNX format and int8 precision, or do you have other plans on the quantization?
Since you said ONNX, ONNX is like de facto. All the people will prefer ONNX, but it depends on the frameworks. There are, for example, if you're going for TensorRT, it will be mostly ONNX. But if you go for different accelerators, people have their own frameworks, which can either work with directly from the PyTorch model or TensorFlow model, but it can also support ONNX model. So it depends on the framework that we are going to use for quantization. But yeah, mostly ONNX will support all framework, all SoCs. Yeah.
Great. Thank you very much, Selventeran. A round of applause, please. Thank you very much.
Thank you.
So our next presentation is from Ishizuka-san from Astemo. Sorry, it's Mr. Iwakami-san. Thank you. Welcome to the stage. Round of applause, please.
Hello everyone. Hello everyone. I'm Ryuda Iwakami from Saitama University. Today, I'm here to talk about collaboration between the Autoware ecosystem and AUTOSAR AP via open source DDS SUM IP bridge converter. Here's the outlines. First, I will describe background. Recently, autonomous driving technology has been attracting attention from all over the world. Research is being actively conducted, and demonstration tests and public road tests are being conducted. These movies shows example of demonstration tests. The first in the background is AutoSteer AP. AutoSteer AP is a platform used as standard in the production of autonomous vehicles. A license is required to use AutoSteer AP. AutoSteer AP lacks documentation and tools. The top part of this figure, the functionality part, is called application, and SUM IP protocol is used for communication between applications. And next is ROS2. ROS2 is middleware for robots used in autonomous driving systems. Basically for free of charge due to open source software. ROS2 has a wealth of documentation tools. The top part of this figure is called node functionality part, and DDS protocol is used for between nodes. Next is publish subscribe model. In this model, data is exchanged via intercomponent communication data bus called a topic. Sending is called publish and receiving is called subscribe. Next is SAMIP. SAMIP is a communication protocol used in AusIP. SAMIP has service discovery functionality, which is called SAMIP SD. As shown in the figure, the sending application first sends offer message, and the receiving application send find message. When offer service matches find service, the receiving side makes a request and data is exchanged. Next is DDS. DDS is a real-time communication protocol used in ROS2. DDS manages the matching process. As shown in the figure, when a node is created, the middleware automatically performs search and matching. When a receiver is found, the sent topic is subscribed by the receiver. Based on these considerations, we raised the following issues with existing development method. AusIP has its disadvantages. Fewer convenient document and tools compared to ROS2. This makes it less efficient than ROS2 development using ROS2. However, AusIP currently is the standard of development in the production of autonomous vehicles. Despite this, the de facto standard is in research is ROS2. This situation creates a major problem that the results of research in ROS2 cannot be directly applied to development. Next, I will explain the proposed framework. Here is contribution of this our framework. First, I will explain collaboration between AusIP and ROS2. This figure is the architecture of the collaboration framework between AusIP and ROS2. Since both platforms use a different protocol, SAMIP and DDS, we use disk bridge converter to perform the conversion and realize communication between different platforms. The bridge converter is implemented as a node on the ROS2 side. The bridge converter uses vSAMIP to perform two functionalities. First, addition of SAMIP SD functionalities. Second, conversion of message types. Second, I will explain the using ROS2 tool in AutoSteer. We use ROS2 tool for recording and replaying data. This tool records communicated data in a bug file, which can be replayed at any time for efficient debugging. We also use RVS, a ROS2 tool for data visualization. Third, I will explain the support for various custom messages. We took this approach to support various custom messages. We use FIDL file to support various data types. Our framework generates configuration files to facilitate the use of the bridge converter, proposed bridge converter. Next, I will explain the evaluation. This is evaluation environment. The roster side uses PC1, PC2, and QEMU is used for AutoSteer AP environment. This is the system used to evaluate the performance of a proposed bridge converter. We measured the conversion time and communication time using two computers. Using the time between 1 and 2, 2 and 3, 3 and 4, the proportion of the conversion time to communication time is calculated in this graph. We use seven sizes of point cloud data ranging from 4 kilobytes to 256 kilobytes. The communication time was a few milliseconds for all data sizes. The communication time, most of values are within 1% or less. The result indicates that the conversion time is a small latency compared to the communication latency. Next, we evaluate communication latency with AutoSteer application. Communication latency with application is calculated. Convert DDS to some IP by bridge converter. We use 10 sizes of string data. Despite the small data size, the latency was higher than expected. The latency does not increase data sizes. Data size increases. Considering the performance evaluation of the bridge converter, it is considered that the communication bottleneck is not the bridge converter, but other parts such as QM. This is the use of lossbag. Data emitted from lossbag can be received by AutoSteer AP application, converted by the data with the bridge converter. Next, as a use case, we describe the collaboration with Autoware. Such a case is use collaboration with Autoware. In this case, for simplicity, we will get the self-localization data from Autoware. The data converted by bridge converter sent to AutoSteer AP application. Then the application returns the path information. The data converted by bridge converter and that sent to Autoware. Here's a video showing this in action. This is Autoware loss side. This is AutoSteer AP side. This is loss side. This is AutoSteer AP side. First, Autoware determines the position of the vehicle and send the data of the vehicle to the AutoSteer AP. Next, AutoSteer AP starts up the receiving functionalities. And when a receiving functionality is started up, it can be confirmed self-localization data sent from lost side has been received. And next, the sending functionality is started up, and the path information is returned. Path information converted by bridge converter and received by Autoware and displayed in this way. This is a version automatic generation of the configuration file. Finally, here are the conclusions. Since different platforms are used for research and development, a result of research cannot be directly applied to development. A proposed framework realizes a collaboration between AutoSAR AP and ROS2 software like Autoware. Here's a summary. The bridge converter is available as open source on GitHub, so please take a look if you are interested. In addition, we plan to release CART, a tracing framework for the AutoSAR AP and ROS2 collaboration environment in the near future. Thank you for listening.
Thank you very much for the presentation. Are there any questions on Zoom or in the audience? Yes, you have a question?
So thank you for the presentation. So I have a question not directly regarding Converter itself, but so you had a demo with the communication of localization and planning on the IT side. Is the planning work done? Is the planning done the AUTOSAR side? Is it like a converted ROS Autoware planning mode, or did you kind of write from scratch for that purpose? So I was just wondering if how much effort is needed to, for example, convert ROS2 node into AutoSAR IP applications. Yeah.
Are you saying that why is bridge converter is implemented ROS2 on ROS2?
Oh, no, my question, ちょっとじゃあ日本語で、コンバーターそのものじゃなくて、もし仮にロス2のノードを、オートスタンドに完全に移植するっていったときに、どれぐらいの労力があるのかっていうのを、ちょっとそもそもちょっと感覚値とか分からなかったので、そこをちょっと知りたいな。それが大変だったら、ブリッジやった方が楽っていう話になりますし、そこが、大変だったら、当然これを使ってまず試したいっていう話なので、その辺のちょっと前提の話をちょっと知りたいなと思いました。
はい。じゃあ、ちょっと日本語で答えさせていただくんですけども、まず、そうですね、労力としてはかなり大変なものだと思います。前提知識のところで、プロトコルが違うっていう説明させていただいたんですけど、そもそも結構土台の部分が変わってくるので、とても大変なんじゃないかなっていうところで、実際ブリッジの方が楽だとは思います。加えて、ブリッジにした理由の一つとしては、実験段階とか機能、開発段階で、ロス2のツールを使って、AutoSAR AP の開発をもう楽にしようみたいな意図もあって、そういったところで、今回はブリッジで実装しました。
So just in case, maybe I can translate the answer in English. So the answer was that it's actually very hard to convert the ROS2 node into the AutoSAR API applications. But that's not the only reason why they created the converter, but it was more about utilizing a lot of tools from ROS2 community because they are quite useful. So they wanted to make sure that you can utilize those community tools for the AutoSAR AP development.
Thank you very much, Zenoh-san. Thank you very much. That's very nice.
Thank you.
Round of applause, please. And next to the stage, I'd like to welcome Mr. Bucci from Kickoff. Round of applause for Mr. Bucci.
Hello, everyone. I feel very lucky today to be in Nagoya, actually. My mother was born here. It's been a while that I was here last time. I'm also been long in agile development industry. And so Toyota has a lot as the origin of agile development process with the Toyota production system. So that kind of made me brought to the go to the Toyota Industry Memorial Museum, actually. That's very nearby. If you have a chance, it's really nice to go have a look at that. I saw that around like 1930s to like 40s, 50s, there's like a lot of long time to for Toyota to come up with the initial development of their car. And I kind of feel that this Autoware decade that's been passed is really an accomplishment. I like to that. But the difference here is that it's open source and it's a collaboration that we're making as speeding up the innovations ongoing. So that's really a privilege to be here as well for me to present this. So AosEdge, possibility of flexible and continuous AI model update with AosEdge. I'm Kawabuchi from EPAM Systems. EPAM is a global digital agency. We do a lot of digital transformations in various industries. But what I'm representing here from our automotive team, which is a very niche expertise team that's been working actually around this decade in the automotive industry. And they've been like promoting to use Zen hypervisor for the automotives is what they started doing around 10 years ago. So with that in the background, I'd like to start my presentation. So where we are, as everyone's been saying, end-to-end neural network models are coming to the autonomous driving. And it's taking off in open source and paving the path is what we're seeing right now. But to go beyond, continuous update and deployment is something we need, of course, to keep improving the models that make sure that they work safely, make sure that they perceive the sensors and everything nicely, of course. So, of course, modular microservice architecture is a key here, and that's, I think, what's been built right now. And the system, of course, here is that you deploy, update, you deploy it, you get data, you improve from the various data from the various vehicles. You keep validating in your cloud virtual environment, and you put that back to the vehicles as updates. But I think you need to do that in a modular way so that you can increase the pace of these updates and make sure things are working nicely and safely always. Okay. So the challenge here is that, but we're still working with automotive and embedded, which has a little bit of different context to cloud. And there are issues to overcome. So limited resource, of course, it's a very limited resource, although the power is increasing in the vehicle, but it's still limited. Not always connected. The vehicle has a lot of environment issues. Sometimes it's going to need to be kept in your garage for a decade maybe, and once it'll need to be spring back right away. Security, of course, things are coming connected, digital. There's going to be a lot more issues around security. Mixed safety, because your models are going to be controlling the vehicle passage. Of course, safety is a concern. But cloud origin tools, we're seeing that deployments are done with cloud origin tools. And I think these issues are not always fulfilled by such tools. So AosEdge, mixed critical deployment orchestration platform can work for that with collaboration with the Autoware. We're a blueprint of the SOFI consortium. We're also working with the Digital Auto Playground. We're in progress with the Eclipse XDV blueprint right now. Just a background. Let's go. AosEdge itself is a quite holistic product solution, and it has container and orchestration designed for automotive, lightweight, OCA compliant. It has mixed safety based on Zen hypervisor and Zephyr RTOS. We do isolation with Unicorn technology But still, we have a orchestration framework that's unified with the Linux container. So previously, I think in the previous presentation, we heard about multi-core. So when you have a multi-core, we enable dynamic rebalancing within those multi-node HPCs. And of course, that can be done with all the configurations, affinity, and heterogeneous environments as well. Unified configuration, OTA management, fleets, FOTA, SOTA, those are managed in the cloud nicely. And I think a lot of these kind of systems right now in the industry is patchwork over these decades of the software evolution. But I think we are thinking that it's time to unify that in a nice way so that we can go into a further innovation of the decades. So going on to how this would collaborate with Autoware. So this is just a high-level architecture that we always see. Yep, and so in the middle, this is just a very rough representation of how it is for the newer network models that I see. And with the yellow boxes, they are modular is how I see them. The point is that we want to update them by each module. So with AosEdge, what we have is the AOS core on your vehicle, on your HPC, and that will sit next to these softwares, middlewares, and it will orchestrate these deployments and the orchestration within the vehicle. AOS Cloud will be managing these deployment configurations and the update campaigns, which of course need to be managed with control by the OEM, and OEM or the tier ones or any software providers can be on board by approval of the OEM to deploy these modular models. So also QM can be run with a Linux container. ASO software, safety softwares should be run on a unikernel as we're doing with the Zen hypervisor and the Zephyr RTOS. So if you want to get started with this, we have all this already up and running as a platform for you. Website is there, documentation. We have a whole lot of technical documentation of how this is working. We have AOS Core totally open source, so you know what we're doing on with this. There's quick start information. There's a VM that you can install on your Linux PC and start using AosEdge right away. Also, we recently released this Raspberry Pi 5 Yocto layer and also a binary that you can download so that you can actually use your hardware to try this out. Okay. Connecting to the Autoware, of course. So just high-level steps of how this can be done to try your modular updates with your Autoware platform. So it is still an assumed procedure. So I hope that the community can give it a try with this. So step one, you need to prepare your Raspberry Pi device, of course. Probably you like to have an AI hat extension so that you can run the actual inference process. You can go to the Meta AOS RPi repository to get the Raspberry Pi Yocto or to build your image, or maybe you can use our image right away, downloadable. Step two, you can go to our website to register to AosEdge. So we have the AOS Cloud as a SaaS for evaluation purpose. Of course, if you want to have a proprietary use of it, you can deploy it if you want to later on. But basically, for ease of starting, we have this SaaS service for you right now. You can, so once you get that account, provision the flashed Raspberry Pi to the AosEdge. Step three, prepare Autoware and the neural net models. So this is, I think, the very meaty part of this. And you need to, of course, adjust the Autoware components for deployment with the AosEdge. I believe you should probably start with some simple setup so that you can quickly validate, of course, and also to fit into the small Raspberry Pi environment. Step 4, deploy and update. So once you got that nicely prepared, you should configure the models as separate containers and configure the resource or the priority and also the networks for communication with each other. We have that all standardized for the AosEdge. And if it's a safety component, you can of course try this unikernel, which works like as a micro VM. And that can be also configured and orchestrated in the same unified manner. Okay. I'm just posting here a reference architecture of our AosEdge and how it can run on Zen, Zephyr, and also Linux environment. Just for some reference, so this is some of the recent publications and also some old publications from the Zen Summit back in 2019. And just as a closure, so I think it's really a privilege to be here, and it's a collaborative innovation that we're working on, and end-to-end neural network modules need to be updated continuously, I think, to be keep improving. So AosEdge, we're here to go beyond with you. If you need anything, if you try it, if you have issues, please let me know. I'm on LinkedIn, or you can see my email right after this. And of course, we have the Raspberry Pi 5, so you can try right away. Thank you.
Thank you very much for the very nice presentation, Rishi. Any questions from the audience or on Zoom? Well, I have a question for you, Rishi.
Sure.
We've heard a lot about SDV, the software-defined vehicle, over the last few years. But listening to your presentation, it seems like there's now the new evolution of the AI-defined vehicle.
Sure, yeah.
Do you see that as the next step of SDV?
Of course, yes, of course, yeah. I think that's why I'm here to talk about this modular update, and that you need the platform for that, definitely, yes.
Great, well, excited to be collaborating with you and enabling this revolution.
Yep.
Thank you very much again.
Looking forward, thank you.
And next presentation is from Injun Lau from Conceptio. Round of applause, please. Thank you.
Oh, okay. So, okay, cool. Hello, everyone. My name is Yejun Lau, and I'm from Inceptual Technology. So the title of my presentation today is Robust Vehicle Weight Driving Resistance Estimation Algorithms for the Trucks. Next, please. Yeah, so first, let's talk about some motivations. So here in Inceptual, we focused on building autonomous driving system for trucks. And the truck autonomous driving system, in order to make the truck autonomous driving system cost effective, reducing the fuel consumption is essential. And we found out that accurate vehicle weight and driving resistance estimation can help reduce the fuel consumption. And it can also help better control the vehicle and do some vehicle health monitorings. So the current version of our method in Inceptual Technology is actually not that good. It's not quite accurate, and it takes very long time to converge, and it can be very sensitive to the measurement noise. So this leads to developing a more robust estimation method. Next, please. Yeah, so here is some background knowledge. So in the figure 1, we can see there's a truck riding uphill. And on the left side, the first equation can be used to describe the truck's longitudinal dynamics. So here, the M is vehicle weight, AV is acceleration and velocity, lambda is friction constant, and theta is the road slope. And the wheel torque T omega can be calculated using the transmission gear ratio, engine torque, and engine torque loss. And I also want to mention that this equation is only valid in certain conditions, such that the vehicle is driving straight, no braking operation, and the drivetrain is fully engaged. And without loss of generality, we can write this dynamic equation as a linear regression form. So the vector x here is what we want to estimate. Next, please. So based on this linear regression form, so here we have on the left side we have the y, which the true value can be calculated using the onboard sensors. So for the phi, it can also be calculated using the signals from the CAN bus, and we can also have the initial guess of the x. So in a word, we can get the true value of y and the estimated value of y. And we can use the discrepancy between these two values to update our estimated x, which here we call the x hat. Next, please. And the most straightforward way is to using the gradient descent, which is shown here. But it suffers a main drawback, which is the learning rate is very hard to tune. And in our experience, that for different type of trucks, the learning rate needs to be retuned. Next. So another popular choice is the Kalman filter. So here we assume the linear regression model can be approximated by a random walk model. And then we can use the Kalman filter to update the Kalman gain and the X hat and also the covariance matrix P. But this method also suffers a few drawbacks. So one of them is the measurement outliers can have a very large impact on the results. And this method cannot handle the insufficient excitation conditions. And in the next slides, we will introduce what we did to solve these two difficulties. Yeah, so first is the measurement outlier. So essentially what we did here is to cap the error function to zeta. So here we choose the robust Hilbert estimate function, which is shown here. And in the figure, we can see when the error function exceeds zeta, and then we treat it as equals to zeta. Next, please. And next, we will introduce how we handle the insufficient excitation. So here we introduce the definition of the persistent excitation. So the equation here that essentially shows that the phi t times phi t transpose is inversible. But this condition is not always satisfied. So for the extreme case, when phi equals to 0, the Kalman filter follows, the Kalman gain becomes 0. The P, since the Q is a constant, so the estimation error P goes up. And so when the excitation returns, the Kalman gain will be very large. And this will make the estimator very sensitive to the measurement noise. And this is not what we want. So essentially what we did here is we changed the formulation of the Q to make it such that when phi equals to 0, the Q is also equal to 0. Next slide. So this is the pseudo code for the robust Kalman filter that we propose. So we can see there are two red rectangles. So the top one describes how we minimize the impact of the measurement outliers. And the second one is the formulation of the Q. By using this formula, we can deal with insufficient excitation condition. And the detailed convergence rate analysis is presented in the reference one. There are several tuning parameters on this algorithm. So the first one is the R, which is the measurement noise. This is the same as a regular Kalman filter. And we also have the zeta, which is the upper bound of the acceleration error. Yeah, and in our experience, the reasonable choice of the zeta is between 0.5 to 1. And the PD is design point of the estimation covariance matrix P. So essentially, the PD is always diagonal and is the lower bound of the P. And theoretically, you can choose PD as small as possible, but in our experience, choosing it equals to 0.1 is good enough. Yeah, next. Yeah, I guess some of you may be bored with the formula, so let's see some real life examples. So this is So this is the estimation algorithm results in a real truck. So the weight of which is 40 tons. And in the figures, we can see there are two lines. So the red line is the result from the robust common filter that we propose. And the blue line is the gradient descent method. So in the top subfigure, we can see that our method converged at a much faster rate, and its converged value is very close to 40 times. And in the friction constant subfigure, we can see that at first there is a large spike on the red line, and this is because the initial gas of the vehicle weight is too small. And after 600 seconds, these two values converged at almost the same values. And based on this figure, we are confident that our method outperforms gradient descent. Next slide. And also in Inceptions, we release the robust common filter, which we call RKF, after to many different type of trucks. So this table summarizes some of our data analysis. So the first column is tractor types. So the first of which is manufactured by the Dongfeng Group, China, and the last three of which is manufactured by the Chinese National Heavy Duty Truck Company. And the second column is the number of orders in each tractor type. And the third column is the total mileage. And the last column is the mean absolute error on the estimated vehicle weight. So we can see that all of them is below 2.5 tons. And the lowest is equals to 1.25 tons. And we think this is quite impressive result, since we only using one set of tuning parameters for all different tractor types. And as we have more data on different tractor types, we will do further data analysis in the near future. Next. Yeah, to conclude this presentation, so here we proposed a robust common filter algorithm that can minimize measurement outliers inference and also deal with insufficient excitation conditions. And we found this algorithm can significantly increase the convergence rate and improve the accuracy. And also, based on the analysis we did, we found this algorithm is robust and accurate across different type of tractor types. And I also want to acknowledge acknowledge my fellow colleagues in Inceptual Technology, especially those in planning control team, data scenario intelligence team, and also those vehicle testing team. And I also want to mention that the truck working group will officially kick off at October, so feel free to join us. Next. Yeah, I think thank you guys for listening, and I'm very happy to take any questions.
Thank you very much for the presentation. Any questions from the audience or on Zoom? I have a question. We were chatting about this earlier in the morning, and I was wondering, would you consider applying a machine learning approach to try and model this, where raw sensor data comes in, the model learns some representation of the feature space, and then just spits out the answer?
Actually, some of my colleagues had done part of this job, and they also published a paper. But the problem of that method is that the test mileage on that method is still low. So we do have some plans to test this method on a large base mileage, and probably in the near future you will see a hybrid method which integrates our common filter with the machine learning method. Yeah.
Great, thank you very much. Do you have another question from the audience? I'll just give the microphone over. Yeah.
Thank you. Very briefly, at the beginning you mentioned that there are some road configurations. You saw the case of a truck going up a hill. You mentioned there are some cases that are not supported yet. Can you elaborate more on what kind of challenges are you still considering for the future extensions of this work?
Yeah, so essentially, like I said, like some of my assumptions that only one truck is driving straight and there's no brake force, our method is valid. This is because we have a bad estimation of the brake force. And also, when the car is turning, you also need to consider some like side slip angles, which we didn't show here in our formula. So yeah, in the near future, yes, as we have a good estimation of the braking force, we can definitely incorporate the braking operations. Yeah, and in terms of the turning, some of my colleague has done some job. Yeah, we also in the near future we also will include the turning conditions in our methodology. Yeah, for sure.
If the truck is articulated.
Yes.
If it is articulated,
Mhm.
would that also change the communication they have?
No, I don't think so. We can use the formulation we did, because I mean the formulation is actually a simplified version of the truck dynamics. Yeah.
Okay, thanks very much for the presentation. And next presentation is, I believe, online. It's Shiwai Tengyinku from AosEdge. So over to you, Shiwai.
Yeah, sure. Can you hear me?
We can hear you.
Okay, great. Then let me share my screen first. Okay, can you see my slides?
They're just loading. We can see them now.
Yeah, great. Okay, hello everyone. It's my pleasure to be the first Autoware conference here. And yeah, today I want to share with you is about the new communication stack for the Autoware, which is Zenoh. So, okay, so my name is Chen Kuo, and you can call me CY. And now I'm the editing technical representative at Autoware Foundation, and also act as a software engineer at DataScale. So today, I think I want to discuss 3 questions with you. The first one is, what is Zenoh? And then I will give a short introduction to Zenoh. And then I will discuss why now Rust2 adopts Zenoh. And here is some benefits of using Zenoh and the issue Rust2 community face in the DDS. So I will explain that in this question. And then I will move on to the ongoing projects for the integration of Autoware and Zenoh later. Okay, let's start from the first one. So Zenoh is a neural network overhead protocol. This is the name, and it's invented and maintained by DataScale, and it's fully open source, so it's hosted under the Eclipse Foundation. This is the data-centric network protocol. We will discuss it later. And then it is written in Rust, but it also supports different language binding like the C, C++, Python, and Java, and so on. And Zenoh can also run in the embedded system. We have the version called Zenoh Pico. And so it doesn't need too much footprint, and it can run on the constrained devices. And this is sometimes used in the autonomous vehicle. And also, Zenoh supports various network technologies, including TCP, UDP, TLS, QE, and serial. So in the OSI 7 layer, you can see it's above the data link layer. So it supports various technology, and the most important one is it also supports shared memory communication, which is very efficient. So we will discuss the communication pattern here. And for the Zenoh, it's just something similar to the Rust2. So we can just use the publish and the subscriber, and just put the data to the topic. We call it key expression in Zenoh. On the other side, it can just subscribe that key expression and get the data. And then just like Rust2, we have the Rust2 service, we can send a request and get a response. So in Zenoh, we have the get and queryable. So we send a request with get, and the queryable will respond the computation result to the sender. And then also Zenoh can support put the data into the temporary storage, for example, like the memory, database, or file system. And on the other side, you can just try to get the data from the storage for the historical data. So it's similar to the QoS in the transient local in the Rust tool. So since Zenoh supports various communication patterns, so it is very useful to support any kind of user scenario you want. And here, Zenoh, we have the three key roles in the Zenoh topology. One is peer, and peer is something like it can run in under your local network, and it can detect each other automatically, and then it can have the data transmission peer-to-peer directly. And then another role is client. Client, when we want to have some resource limited scenario, for example, we want to use less memory CPU, then we can use a client. It disable the discovery function, but it can just run in the more resource constraint scenario. And for the router, when we want to communicate with the external network, router is a great way to hide the information of the local network information. And then you can route the message to the other side. So it's very useful when we want to use in the internet. So the next one is then why Rust 2 community wants to adopt Zenoh. So here is the architecture I think you are very familiar with because it is a Rust 2 architecture. In Autoware application layer should be Autoware, and then we have the Python and C++ client library, and also we have the middleware library, middleware, and the middleware can support the various protocol, first DDS, second DDS, and also Zenoh. So now, what's the issue we have in the DDS? So for example, I just take in the, for example, like the autonomous vehicle scenario. If you want to running the multiple AutoWares at the same time, sometimes it's not easy to manage, and so perhaps you will face Rust topic conflicts, something like that. And also, DDS requires multicast functionality by default, so it's not able to run in the private 5G, and also it cannot traverse the internet. So because it needs a multicast, and the multicast can only run in the local network. And another important one is that DDS configuration is very, very complicated. So most of the time, you don't have the out-of-box configuration. You might need to do some tuning on your configuration. So this is a DDS issue faced by the community. So the community has the polls, and finally they selected the Zenoh among all of the various protocols. And here is a table about the comparison of each protocol. Rust 2 community, they list the requirements of each feature they need in the Rust 2. You can see that in this table, most of the feature, all the features Zenoh can support. But for other protocol, sometimes it's just have the limited support or doesn't support. So this is another reason why Rust 2 decided to choose Zenoh as is another protocol alternative. So here, let's discuss about the RW Zenoh architecture. Now, in the Rust 2, in Intrinsic, we developed an RW Zenoh for the next generation protocol layer. So you can see that in the architecture, we have the Zenoh router on each host. And for each Zenoh router, it can act as a discovery server in this scenario. So for the node 1, node 2, node 3, they can discover each other by connecting to the Zenoh router, and then they can build a direct communication with each other directly. So the data transmission doesn't need the Zenoh router. However, when you want to communicate with an external network, then it will require the Zenoh router to forward your message to the other side. The reason why we have this kind of design is that we can use the Zenoh router as a network gateway to do some feature like the traffic filter or access control for the security sake. So this is the reason why we have the Zenoh router for each host. But just as I said before, Zenoh is very flexible, so we can have a different configuration if you want by tuning your configuration. It's easily to switch the RW Zenoh by using the RW implementation environment variable. So this can be apt installed now. If you don't want to, if you don't want to change your system a lot, you just want to try the feature in the Zenoh, we also provide the Zenoh ROS2 bridge. So you can keep your existing system as usual, and you just need to run a bridge here, and then the bridge will seamlessly transform the DTS message into the Zenoh message and send to the other side. So I think this is a very easy way for you to try the feature of the Zenoh. Okay, so let's move on to the ongoing project in the Autoware here now. We have 4 ongoing projects for the Autoware with Zenoh. Okay, the first one, remote control and visualization. Sometimes you want to manage your vehicles on the edge from the cloud. So you need to traverse the internet. And DDS cannot do that by default because just as we mentioned before, the DDS needs a multi-case and it cannot directly do that. So Zenoh can help in this case. So we can run the Zenoh on the Autoware side and also on the RV side. So the control message we can send from the cloud to the vehicle, and the status of the vehicle can be visualized on the cloud. Now we are also have this kind of scenario in the OpenAD working group. We work with a group member to showcase this kind of scenario. You can see that there is a QR code here. Here's a link for the detailed tutorial if you are interested in this. Okay, so the next step, the next project, we have the multiple Autoware management prototype here. If you want to manage multiple Autoware, you might have some topic conflicts. We use the namespace in the Zenoh to add a prefix of every topic for every Autoware. So you can just decide which message you want to go to which vehicle. So this is the benefit Zenoh can bring here. And you can see that on the GIF on your right-hand side, that we can just assign the vehicle, the goal of the vehicle on the management system. And then you can see that on the RVs, we can specify the destination of each vehicle, and then they can just give a planning route for their vehicle. Yeah, the demonstration are also open source, so you can just check the link here to see the detail. And the third one, now in the in today's there are so many topics about the AI, and for now Autoware have the end-to-end AI development, and also Zenoh can help on this scenario. Zenoh can provide high performance with the shared memory in this scenario, and also it can be potentially certified in the future. So now we are also work with the private owned vehicle working group, and then we want to demonstrate how Zenoh can benefit for the AI pipeline here. And the final one, and is the most important one. We did a lot of experience on how to replace the DDS with Zenoh. So we try to replace RW cycle DDS with RW Zenoh here. And this can enable several WZNO's benefit. So traverse internet, share memory, or traffic filter, or also like in the wireless scenario. Now we have put the tutorial on the official Autoware documentation. And so you can, if you want to give it a try, you can also check the official documentation and just try it and run it step by step. So a short conclusion. Zenoh can enable your autonomous driving vehicles with a very key feature here: performance exit control, internet, or also wireless environment. If you want to give it a try, you can try your system with the Zenoh RAS2 bridge first. And if it works as expected, then you can give it a try to migrate to the other Zenoh. Yeah. So thank you very much. And if you want to access the slides, you can scan the QR code here. Yeah. Thank you.
Thank you very much for the presentation, Shiwai. Do you have any questions from the audience or on Zoom? Yes, we have a question.
Thank you for your presentation, and I was so excited because Zenoh is very promising technology. So we would like to apply Zenoh into Autoware deeply, but we need to support the latest roster distro. So how did you test the Autoware with your Zenoh currently?
Do you mean the distribution of the RAS2?
Yeah.
Yeah. Okay.
They support roster humble so far, so.
Yeah. Actually, it supports RAS2 humble now. It is a tier 1 support in the RAS2 community for the QTID, but it is also backward to the RAS2 JC and also the RAS2 humble. So you can just use the RAS2 humble directly, and it also on the RAS2 build farm. So you can just use apt install to install the Zenoh in the RAS2 humble.
Wow, so I'm sorry, I don't know that information. Thank you very much.
Yeah. It would be great if you can give it a try. Welcome for any feedback.
Thank you very much. Thank you very much. Any other questions from the audience? Yes, I'll just bring the mic over. Okay, thank you for your presentation. I just barely heard about the Zenoh. It's just right now. I'm curious about whether the internal communication within the same host supports the. I heard that it supports shared memory, but is it based on the zero copy or not?
It's now for the shared memory feature is not enabled by default, but we are discuss with Intrinsic about whether we should enable it by default or not. And then, but you still can enable it with the configuration. But if you want to mention about the zero copy, I think no, it still needs a copy to copy your data into the buffer, and then the buffer can send to the other side, and the other side can do some can get the message. But if you want to achieve the real zero copy, you might need to adjust the API on the RAS2. So you need to change the API you use on the RAS2 layer, and then it should be able to support the zero copy.
Okay, it does. So by default, it does support the zero copy by default, but we can expect by the result or private patch modification to support it, right?
Yeah, yeah. So yeah, because you still need to leverage the Rust2 zero copy API. So it just cannot achieve the zero copy without any modification. You still need to make some change on your application layer.
Okay.
Thank you very much for the presentation, Shiru. I really appreciate it. Round of applause, please.
Yeah, thank you.
Great, and it's my pleasure to welcome our next speaker, who is Daniel Sanchez from Tier 4. Over to you, Daniel.
Hi, can you hear me?
We hear you loud and clear.
Okay, thank you very much. Welcome everybody. This presentation is titled Towards Open Source Autonomy 2.0, End-to-End Autonomous Driving with Autoware. This presentation will be divided on 4 different parts. First, I will talk about me. Then I will talk about Autonomy 2.0, what is it? And then I will talk about our most recent implementation into Autoware Universe, the Diffusion Planner node, which corresponds to a modular end-to-end solution for Autoware. And finally, I will talk about future works on what monolithic end-to-ends are we planning to implement in the near future into the Autoware Universe software structure. So about me, my name is Daniel Sanchez. I graduated as an electronics engineer at Simon Bolivar University in Venezuela in 2017. Then I got my master's in robotics at Osaka University in Japan in 2021. And since 2023, I have been working at Tier 4 as an R&D engineer, basically first in the planning and control team, and more recently on the end-to-end model development and integration team. So about autonomy, what is autonomy 1.0 and 2.0? Basically, we can define autonomy 1.0 as the dominant approach today for realizing autonomous driving. It basically consists on dividing the different driving stack into components of perception, localization, planning, and control, which are often stitched together using rule-based logic. So think about if and else's. And more recently, there is Autonomy 2.0, which is a new paradigm that represents a shift from rule-based design to data-driven design. So instead of engineers manually crafting the driving logic, we use real-world data from expert drivers in order to make machine learning models learn a certain way of driving. So based on those two definitions, we also define 3 different kinds of solutions for autonomous driving. First is the most well-known, which is robotics-based approach, which is mostly rule-based implementation of software, with sometimes machine learning-based solutions in perceptions. These kinds of systems have the advantage that they are easy to explain and validate because you can directly read the code and see how the ego vehicle is supposed to behave. However, they have shown to have low performance in edge cases that have not been thought about by the engineers developing the system. These kind of systems can be said to be good for cargo delivery and also simple and well-defined ODDs. Moving further along the machine learning-based solutions, we have what we call the modular end-to-end, which basically uses machine learning-based not only in the perception side, but also on the planning software stack. These kinds of solutions tend to have good performance on edge cases, and they have moderate explainability and validation. So it's a little harder to understand how the vehicle will behave because the behavior is determined by a neural network. And also the bad point about these systems is that even though their performance on edge cases can be better when compared to the robotics-based approach, they still don't exploit the full potential of machine learning-based solutions. This kind of modular end-to-end implementation tends to be good and compatible with level 4 autonomous driving solutions. And finally, we have the monolithic end-to-end solutions, in which a big monolithic machine learning node encompasses the beginning of perception, and its final output is either a trajectory or a control output. These tend to have the best performance, or their potential is the highest, and they are better directed at level 2 human supervised autonomous driving. However, they suffer from the lowest explainability, and they are very difficult to validate. So each system has its pros and cons, and our goal is to implement both modular and monolithic end-to-ends into the Autoware software architecture. So now I will talk about the most recent addition to Autoware, the Diffusion Planner node, which is based on the Diffusion Planner publication. Currently, we enter the public testing on roads part of development. We developed this node to run using TensorRT, and it has an execution time of about 10 milliseconds, which makes it really good for real-time implementations. So how we reached this point? First, we started training this model using not only real data, but also synthetic data, because the amount of hours of data required for this kind of training can be quite high. So basically, we use based Autoware in order to simulate a bunch of random start and go poses, random spawn of vehicles, and also controlled traffic lights, in order to get a lot of synthetic data that has the general traffic rule adherence that normally Autoware shows. Then we perform simulation tests using the synthetic data for training, and also using real data for training for specific edge cases. And we confirm that it's possible to perform lane following, but also avoidance. So as you can see in this video, the vehicle is able to avoid the different cars around the road, and when there is no further danger, the vehicle goes back into its destined lane and reaches the goal position. We also tested that the vehicle is able to stop at traffic lights. So as you can see here, there is a red traffic light, so the ego vehicle reaches close to the stopping point, stops completely, and then when we change the light to a green light, the vehicle is able to continue. We also tested the cruise capabilities of the model. So basically, you can see the ego vehicle reaches a high speed, but when I spawn a vehicle in front of it, it suddenly reduces the speed in order to cruise behind the vehicle in front. But then when this vehicle is removed, the ego vehicle accelerates again and reaches its top speed. And finally, we also did some tests to see if it's possible to perform lane changes. So in here, we set the goal point around like 4 lanes to the right of the vehicle. And as you can see, it starts performing lane change after the other. Since there are like no obstacles or anything, it just goes directly to the lane it needs to go. And then when it reaches the target lane, the vehicle goes in a straight line and finally reaches its goal. So at least we prove that training this model like this makes the model obey at least the most basic traffic rules. Then we started performing tests on private roads. So basically, we grabbed this diffusion planner model, and we tested it on a closed road to see if it was possible to move the ego vehicle, if it was properly compatible with the Autoware software architecture or if there were any issues. And well, we were able to move the eco vehicle and perform several simple tests, as well as traffic light tests. And we were able to assess what were the shortcomings of the model at the moment. And well, finally, we move into a road testing phase, in which, as I mentioned before, we reach around 10 milliseconds of execution time. We're scheduled to perform even more public road tests. I think we have a test tomorrow. So we will see what are the shortcomings or possible edge cases of this model and try to improve them using real world data. And finally, I would like to talk about future works. We are also planning to implement monolithic end-to-ends into Autoware. Currently, we are working on two different solutions. One is BAD and one is the diffusion drive. We have implemented it on Tensor RT, and they have reached an inference time of around 20 milliseconds. So we believe they will be suitable for real world implementation. With BAD, basically we train the BAD model using Carla, using the bench to drive dataset. This is like a small sample video. We also improve the Autoware Carla interface in order to support BAD. And currently we are conducting these kind of tests. There are still many details that need to be improved, but this is a work in progress, and we are hoping we can merge some working solution into Autoware maybe by the end of this year. On a similar note, we are also working on Diffusion Drive, which is a more state-of-the-art solution compared to BAD. At least in publications, it seems to have reached better performance than BAD. We are currently training in using the NAPSIN dataset, and we are also testing using the Carla-based environment. We also hope to be able to merge a working TensorRT solution of Diffusion Drive somewhere in the near future. Well, I would like to close this presentation, just giving some credits to the creators of the Diffusion Planner, the BAD, Diffusion Drive. And also, if you're interested, you can visit our GitHub in order to see the Diffusion Planner main fork repository, in which you can use to train your own Diffusion Planner model using your own raw specs. Well, thank you very much. Do you have any questions?
Thank you very much. Thank you very much, Daniel. Is it on? Can you hear me?
Yes.
Yes. Excellent presentation, by the way. So does anybody have any questions from the audience? Yes, we have a question. If you can just say your question, I'll speak it to Daniel, or if you'd like to come up.
Thank you. Nice to see you again. Thank you for your presentation last time in the Autoware workshop. So it's Alex from Gifu University. So very quickly, the diffusion-based methods have maybe one of the challenges is the pruning task of the generated hypothesis for the planning task. So you can generate multiple hypotheses using the diffusion method, and then you select, for example, among them. So based on the different data sets that you have been evaluating, and also the real world environments, etc., have you have any issues on that part of the method?
You mean like choosing what is the best output, isn't it?
Yes, right.
Well, right now, since we have set the temperature of this model to be static, we are planning to play with that in the future. Right now, you wouldn't say this is a multi-model output. I mean, you can have slightly different outputs, but they tend to be mostly the same trajectory. But regarding this question, in the future, we are planning to experiment a little bit more about like multimodal generation. And that's why we are also developing the generator selector framework, which is, how to say, maybe rule-based or maybe a machine learning based or some kind of hybrid way of choosing what is the best trajectory at a given scenario or situation. If you have like more questions about that, I will invite you to look at the issues on Autoware, where we are currently discussing and trying to implement the different nodes that will represent some kind of selection of different possible trajectories for the ego vehicle. Does that answer your question?
Yeah, thank you. And just my final question, there is another one in the chat. Are you planning to include language models into these future approaches for end-to-end driving?
Language models?
Large language models, LLMs. For example, BAD is among the different, one of the existing popular end-to-end implementations. We have been testing that. We also develop a new one with language model. We call it BLAD. So large language models have been applied into end-to-end driving very successfully for the past 1 year. So do you have any plans in the community to introduce language models into the end-to-end driving task?
I believe this is on the talks right now. It's hard to choose like in what specific model we are going to focus our attention. On the nearest future, we, as I mentioned, at least at tier 4, we're working at BAD and diffusion drive. But yeah, this is not out of the question, and it's one of our, how to say, something we are looking forward to do. But there are no concrete plans on which specific model we will start implementing at the moment. One of the main issues is that, well, you require large amounts of data for these kind of solutions. And as I mentioned before, like the validation and the explainability tend to be quite difficult. But I believe in order to advance Autoware and keep up with the latest advances on autonomous driving, this will be in the cards.
Right, thank you. There is one in the chat.
So we had a question from Sergey about data synthesis and training.
Sorry?
Yes, maybe I can you hear me? Maybe I can repeat the question.
Yes.
Yeah, Daniel, you mentioned that you are using for testing the synthesis the data of using the tool like Kara. And my question is is there any way that you would load some available city like Tokyo, go into the public authorities and pick it up? There's some kind of the file and load the whole city into the environment. Is it available on your site, or have you tried to do this?
Sorry, can you repeat the question?
Can you repeat the question? Okay. So in the Kara, you have predefined cities, so randomly, some scenarios. You may choose also the vehicles. My question, this is the randomly city. What if you would use the real city like the Tokyo, for example? Is that any way that you can, or you have been tried to load, to get the data from the public authorities to load the real city and so create use cases in the real city, not that randomly one? That's my question.
Thank you.
Yes.
No, well, at the moment we have only used like this public Carla data set, which, as you mentioned, it's kind of random. It doesn't represent a real location. It might be interesting to use like a digital twin of certain cities or certain parts of the city. But at the moment, I mean, this is for BAD and diffusion drive development. This is not necessary for diffusion planner because you don't need this photorealistic like camera. But yeah, I mean, I believe that in order to do like, how to say, more solution-oriented implementations, this might be advantageous. But at the moment, we haven't tried that.
Why was my question basically? It's all going to the homologation, if you use the kind of the real data, that is the process of the homologations, I'm assuming is easier rather than the using the virtual one.
Yes, yes. We are currently on the testing phase, and we're using these open source, how to say, datasets because they are big and they produce, how to say, a starting baseline that we can use to train these models. I think the biggest issue with training is the amount of data that is necessary in order to get like a decent solution. But yeah, I understand your recommendation. I think it's the way to go, but we are not at that stage with BAD or diffusion drive at the moment.
Okay, thank you very much. Appreciate it. Okay.
Okay, thank you very much for the presentation, Daniel. Round of applause, please.
Thank you.
So good afternoon, everybody. I hope you're all doing well. My name is Mohammed Zain Khawaja. 1 second. Let's get the camera set up. I'll sit down. It's easier that way. Can you see me? Great. Thank you, everybody, for joining. My name is Mohammed Zain Khawaja. I'm the Managing Director of Product at Autoware Foundation. It's my pleasure today to introduce our open source framework for end-to-end autonomy. And this is actually a document that we have put together. It's a report which outlines our roadmap to build these technologies in the open source domain and to democratize access to open source end-to-end AI. So I want to begin by just talking about the motivation about why we wanted to do this. So one of our core values within Autoware is to build cutting edge technologies. And we've heard in many of the presentations this morning about the importance of AI, especially end-to-end AI, as being an evolution in autonomous driving. And we believe as Autoware Foundation, we want to be able to offer our member companies and the community at large the option of utilizing this type of cutting edge technology within their autonomous driving implementations. So many of you have seen a diagram like this. This kind of architectural diagram represents the traditional robotics framework for self-driving, where you have various component technologies which are based on hand-coded algorithms and rules that define the driving behavior. And this has been a very successful approach that's really defined the genesis and evolution of self-driving up until this stage. However, one of the other paradigms that has emerged is more of a data-centric paradigm, which we call Autoware E2E, or Autoware end-to-end. And one of the specific goals we have with Autoware end-to-end is to enable what we call level 4 plus autonomous driving. So you've heard of level 1, 2, 3, 4, and 5, but we've introduced what we call level 4 plus. Now, level 4 plus is similar to level 4 autonomy in that you don't have to have the human being engaged with the driving task. The human being is not required to take over. There is an ODD. There are certain conditions which define the operational design domain of the system. But most importantly, the system can safely navigate uncommon edge case scenarios. So it can adapt to scenarios that the system has not necessarily seen beforehand. and that is what we call level 4+ autonomy. And because Autoware is an open source project used by thousands of developers around the world, we want to introduce this cutting edge technology in a stepwise fashion. The reason we want to do this is that it allows us to test the technology and minimize breaking changes within our code base. So we want to start by introducing learned planning. So the green box is where you can have a learned version of the traditional robotic stack. After learned planning, we also can have learned perception with learned planning, and that is what we call component-based end-to-end AI. In the previous presentation, it was referred to as modular AI. And then we have the monolithic model. This is a really big neural network where sensing comes in and driving comes out. And we can support both HD maps as well as 2D maps. We don't want to restrict our community or our users to a specific paradigm or technology, but offer them the flexibility to choose whether they want to use an HD map or a 2D map. If you think about these types of models, there are two broad categories of architectures that you can apply in terms of the actual neural networks. The first is a convolutional neural network, where you have a feature backbone that extracts generic image features and a policy model that takes those features and converts them to a trajectory. This could be a set of waypoints and a desired acceleration or speed profile along those waypoints. And this type of a model is pretty lightweight, and it can support embedded edge devices. The other model is more sophisticated. It's a vision language action model. And this is based on the whole paradigm of transformers, where you can have a vision transformer that extracts elements from the image. You can also have a large language model or a smaller version of a large language model that can take text instructions as an input. For example, change lanes and take the next right turn. And then you have a diffusion transformer decoder that takes those tokens and outputs the final trajectory. And in some of the latest models, you can also output the reasoning behind why the model chose to drive the way it did. And so this is kind of the most cutting edge technology architecture that we have. And we want to look at both versions, both the CNN version as well as the vision language action model version. However, building this technology is not an easy feat. There are many challenges in terms of data, in terms of introspectability, but we believe that it's an important step for Autoware to take on this challenge, and we're excited to be able to build this in the open source domain. Now, one of the other really exciting contributions that we wish to make to Autoware is to go beyond what exists in the state of the art right now with what we call a learned hybrid architecture. So I wanted to just explain what this is and why we think this is going to be the really big next step in terms of end-to-end AI. Now, we've seen a lot of diagrams where sensing comes in and there's learned driving, right? The whole neural network learns the entire driving task. However, this network is essentially a big black box. You don't know what it is. You don't know why it's thinking the way it's thinking. It's very, very difficult to train. It's very difficult to validate because everything is compressed within the feature space of the neural network. There could be edge cases where this network may not be able to perform the way you expect it to. That's why we believe that you would need safety perception, which could be either rule-based or learned, running in parallel to learned driving. Now, the motivation behind safety perception is that learned driving almost typically relies exclusively on vision and cameras as the primary sensing input. However, safety perception can leverage physics-based sensors like LiDAR and radar, allowing for the ability to perceive in adverse weather conditions, in low light, in fog, in snow, in rain, and address those critical edge case scenarios where the learned driving system may have a blind spot. And we have now introduced this concept of what we call a safety guardian that acts as an arbiter between safety perception and learned driving. So imagine the following scenario. You're driving on a highway. The learned driving model says drive straight. However, there is a strange object on the highway. Maybe it's an animal. Maybe it's debris. Your safety perception based on radar or LiDAR can detect that object, sending a signal to the safety guardian which can always err on the side of caution and begin to decelerate or initiate a lane change. This, we believe, will be the most sophisticated and safest version of end-to-end AI, because it does not completely leave the entire driving task to one modality of sensing and one AI model. Even if this model is 99.999% accurate, if you're driving millions or billions of miles, you still won't have that level of safety. But by having two independent streams of perception, two independent streams of safety, you can start to get the levels of safety where you can really not have to worry about the system anymore, so long as it's within its ODD. And we believe that this will be one of the keys to unlocking large-scale deployments of end-to-end AI around the world for different reference use cases. As I mentioned at the start, we want to use a stepwise evolution of the Autoware stack when we're building these technologies, starting from the traditional stack, going to learned planning, from learned planning to learned planning with perception or component-based end-to-end, introducing the monolithic model, and then eventually going to a learned hybrid model, which has safety perception with the end-to-end AI. We've already thought very extensively about how we want to implement this through a generator selector framework. So essentially, this framework abstracts away the entire self-driving car stack. You can think of it as just a black box. It could be a traditional stack, it could be component-based AI, it could be a learned driving model or a learned hybrid model. At the end of the day, all of these models are just producing trajectories. And a selector module is responsible for ranking these trajectories and selecting the ideal one, which can then go to the vehicle. So through this type of an architecture, we're able to support different stacks, whether they're open source stacks, proprietary stacks, and autonomous driving stacks at different level of AI capability, whether it's 100% robotics or 100% AI. Now, we have a philosophy in Autoware that we want to develop this end-to-end autonomous driving by going wide and going deep. Going wide means you want to be able to cover multiple potential use cases, be it personal passenger cars, privately owned vehicles, cargo pods, off-road vehicles, trucks, shuttles and robotaxis, or buses. That's what I mean by going wide. We cut across different use cases. But it's very important that we also go deep. By deep, we mean that we want to achieve a very high level of performance and safety and technology maturity. Specifically, our North Star is level 4+ autonomous driving. So we want to be able to build our end-to-end AI models such that they can be very high performance, very safe, very reliable, and at the same time generalize as much as possible from different domains, from passenger cars to buses, from robotaxis to off-road vehicles. And we're already seeing the first steps on this journey taking place in Autoware, where some of the models developed for on-road driving are being fine-tuned for off-road environments. Another very important aspect of our philosophy as an open source project is that we want to be able to build this technology in collaboration with our member companies. Day one, we won't have the full open source stack. So we want to be able to partner with our member companies to create a full end-to-end solution where, for example, the Autoware Foundation open source models can support a certain part of the task, and the member company proprietary models can support another part of the task. But eventually, this box will grow more and more and more, and then the entire solution could be offered by Autoware Foundation through our open source end-to-end AI. Specifically, we want to break down this ambitious target into a 3-year roadmap, and we've outlined the steps here for each ODD across the 3 years. I won't go into all of the details, but eventually at the end of year 3, we end up with either a learned driving model or a learned hybrid model across all of these use cases. And you may think this is a very, very big ask, but actually if you know this from the outset, you can design your architecture, select your data, and build your pipelines from the beginning to be able to address this vision of going wide and going deep. And we've already made great progress in building out some of these existing technologies within our stack in terms of end-to-end autonomy. So here are some examples of learned perception. Here you can see the outputs of semantic segmentation of the road surface, traffic cones, foreground objects, our monocular depth net, and lane net. We also have learned perception models for LiDAR, including the LiDAR center point implementation. And we also have technologies like AutoSteer, which is presented this morning, which is doing end-to-end future path prediction, primarily for highways using vision, as well as the previous presentation on the diffusion planner. So although we have a 3-year roadmap and we're just beginning on this journey, we have a good head start to begin this implementation in the open source domain. Now, one of the really exciting new technologies that we will be integrating within Autoware to train these models is called neural world simulation. You see, a lot of these models, especially for learned driving, train much more easily in a simulator, right? It's much more easier to teach the model to drive. It can make mistakes, and then it can get better over time. The challenge with simulation is what's called the sim to real domain gap. You see, even if a picture like this simulated city environment looks quite real to the human eye, to a neural network, tiny variations in each pixel will make a difference and will limit the transferability of that network to real-world driving conditions. But by applying neural world simulation, such as style transfer, you can convert the game engine rendered simulation view to a photorealistic camera-like image, and then feed that into the network to learn the driving policy, minimizing the sim to real domain gap. To go even further, we can leverage technologies like Gaussian splatting to create full photorealistic worlds where our vehicles can drive inside this simulation, effectively, this kind of world model. And we can also create variations like injecting different actors within the scene or simulating a different behavior of the ego car in the future. Now, with this type of a simulation, it looks pretty much identical to your original camera capture. And this has been one of the key enabling technologies that have allowed for the latest crop of end-to-end AI models to be deployed in real-world conditions. So this is something we will also be introducing into the Autoware project and bringing into the open source domain. Now, I would be remiss if I did not mention the importance of assessment and safety and benchmarks, right? For any technology, especially an open source one, we have to be very cognizant and aware of the safety implications of what we're building, because this stack would be used by thousands of people, academics, individual researchers, teams, and companies around the world. So we've thought in a very comprehensive way about how we want to go about assessing the safety of this technology. What are the relevant safety standards for us to consider? How do we think about safety throughout the life cycle? How do we go about scenario-based testing, online verification, and many, many other similar constraints? It's a very, very detailed document. So when you get the time, I would urge you to go download it from our website and read through it page by page. I also want to spend a few moments to talk about data, MLOps, and training. So not only do we want to build open source end-to-end AI models, we want to give developers, companies, and the entire community the tools that they will need to train these models on their own by building open source machine learning pipelines that can be spin up on cloud infrastructure. So a member company can take, for example, our open source end-to-end model as a base model, take their own data, take the open source pipeline, and fine-tune that model for their specific geography, their specific vehicle, their specific use case. And we've thought about this in a lot of detail and looking at each step of this pipeline, going from raw data to train models and deploying these models across different vehicles and different ODDs. And it is our ambition to be able to have this entire pipeline running in cloud infrastructure that you can just spin up, add your data, take our reference model, fine-tune it, and deploy it for your vehicle or for your application. Specifically, we want to look at this training in 2 stages. So the first stage is what I spoke about earlier, using style transfer with a convolutional neural network. Now, this is the stage that gets us warmed up. It will help us build our model in an easier way. We won't have to require so much compute. We'll get pretty good performance, and we'll be able to bring these models to market in a short period of time. And stage 2 is where we go for the vision language action model. And there are very good open source data sets available that give us full coverage, 360 vision, trajectories, ego vehicle information that we can use to build virtual worlds with Gaussian splatting and train these sophisticated vision language action models. And then our ambition is to have those models in the open source domain and for the member companies of Autoware to fine-tune those models for their specific use cases. But this is not an easy task. This will have to happen on cloud infrastructure with GPU clusters and data buckets, because one data set is probably hundreds of terabytes. So to do this at scale, you can't really do it on a laptop. I wanted to just conclude by just speaking about Autoware and end-to-end AI, because this is a technology that presents many exciting possibilities in realizing the vision of autonomy. And we've gone and presented our framework here about how we think about implementing open source end-to-end AI. And this entire PDF will be available on our website, so I would encourage you to go and download it. But we're an open source foundation, and it's our mission to democratize access to cutting-edge technologies and to enable globally scalable mobility and beyond for society. So in light of this vision, we invite companies, regulators, industry associations, individual developers to join us in this journey. Building open source end-to-end AI isn't going to be easy, but it will be very, very worthwhile. And so it's an exciting technology to pursue. And I believe that we can really make a mark in this domain by building open source models that are not only good, but that are great, and that can even compete with the closed source players that are out there. And I want to thank all of the members of the Autoware Foundation, the board of directors, the architecture task force, all of the individual open source contributors, the technical steering committee, and the strategic planning committee for all of their inputs in helping shape this document. And I would appreciate, if you have time to have a chat afterwards. If you have any questions, please reach out to me, and please remember to visit our website at autoware.org to find out more. Thank you for listening. Happy to take any questions. We have a question from the audience.
Thank you, Mr. Zhang, for a very, very like. Thank you, Mr. Zhang, for a very inspirational talk about the future of Autoware as well as the end-to-end autonomous approach. So I would like to ask, but I find it really interesting about the neural rendering project that you are having in mind in terms of building a very super realistic environmental simulation. So I'm kind of wonder about your choice of using the NVIDIA Cosmos, because previously when I was kind of thinking about building a hyper realistic environment as well, and I come across another solution called NVIDIA Zen. And note me if I make it wrong, but I feel so I feel it also doing a really good job at building a realistic environment like this. So may you shed a light onto this decision? Thank you.
Sure, thanks for the question. So Isaacson is very widely used, specifically for robotic applications, picking robots, humanoid robots. The goal with this pipeline is photorealism. That's really one of the most important things. Cosmos is just one example of a style transfer network. We may end up making the Autoware style transfer network if we feel that there's room for improvement. And then the next step is to go beyond style transfer, to go to world simulation, world models that actually have photorealism. And you feel like you're driving in a video because it's made from the pixels of your camera. And that's where you have the minimum sim to real domain gap.
I see.
Great.
Yeah, great. Thank you, sir.
Thank
Look forward
you.
to that.
I think if there's a question. Okay, there's a question on Zoom. Yeah. I can read it actually. From the report, most ETE solutions depend on deep learning. How about realizing the planning through reinforcement learning? This seems to be a domain that is not covered in the report. So we've actually spoken about reinforcement learning as a mechanism to train the learned driving model. It's very commonly used. So, the specifics of how we will train and what does the pipeline look like, you can find out more information in the report itself. So I'd urge you to go to the website and please download it from there. Okay, if there's, there's a new one. I think people are somewhat concerned about hallucinations in LLMs. Have there been similar discussions on VLA models? Can the presented multimodal decision making be helpful? Yes, that's actually why we proposed the learned hybrid model, because with any neural network, any AI-based system, you will always have some kind of an edge case. And by having multiple independent systems, you minimize the risk of that edge case, or you minimize the impact of that edge case. And by having different sensing modalities, you can also separate those systems and insulate them even more from each other. So that's why we believe that the learned hybrid model with a safety perception in parallel will be very, very important to be able to address these challenges. Most EDE, I think it's the same question again. You're welcome. I think we can take a break at this point. I'll pass over to Tanaka-san, but thank you for listening.
Thank you, James. All right, so this wraps up the sessions, all presentations before the break. So we have a 15 to 20 minutes break from now. The coffee, snacks, and water is outside here. Then please come back to this meeting room at 15 minutes after the hour, 4:15 in Nagoya. Then we have a keynote speech by Kato-san, Shinpei Kato. Right. Thank you for attention so far. Let's have a break. Thank you. of everyone coming back. So we're going to start the second session. So Kato-san, over to you.
Hello, can you hear me? Welcome to Nagoya. So my name is Shinpei Kato. I founded this community 10 years ago. I appreciate your contributions. So this is 10th year since we. Welcome to Nagoya. My name is Shinpei Kato. I founded this community. Magic. So 10 years, it's been long that, until we came here. I used to teach and work at this university. I taught operating systems. Autoware is often recognized as operating system for autonomous driving, and now it's 10 years old. But I know that operating system, open source, such as Linux, has way longer history. So Linux was founded in 1991, as far as I remember. And Linux is based on Unix or Minix or Multics, which was founded early 70s or even 1960s. This means that traditional operating system, even open source, is 40 years, 50 years, even 60 years. On the other hand, Autoware still 10 years. So I think that we are doing a great job since only 10 years, but Autoware is used everywhere today. I remember that I was using the Linux when I was a student. It was almost 10 years old for Linux, which was still a toy. Autoware, some portion, I think, is still a toy. Students, researchers, they play around. But the majority of the software stack is now getting matured, even used in the commercial services. And even car makers are trying to use Autoware for their mass production vehicles. So I really appreciate your 10 years contribution. I think we are growing. And I personally respect Linux. So I would be, my dream is to have Autoware like Linux everyone is using when they want to build intelligent vehicles, autonomous driving, or advanced mobility. Autoware might be the first software stack they reach out. Let me look back some early days of Autoware. So as I mentioned, Autoware started 10 years ago. At that time, we didn't even have Autoware Foundation, and I didn't even start in my own company. So Autoware was started as a research project from this university. Can you go back? Okay, coming back. You can try to find some participants here who also included in this picture. They are all my students when I was teaching here. This is interesting. I think even my team was bigger than the most of other startups today. 20 people or 30 people. It's quite a big team. And I decided to publish the software that we developed through this university research project. So I personally continue to support university research because I know that new technologies always come from universities. So centers of excellence, we are respecting cutting edge research projects all over the world. So if you are students or researchers, please do not hesitate to join this community, and please propose as many ideas as possible. And we like to accept your ideas as much as possible in Autoware. And after we founded the company first, and we accelerated the development of Autoware. Next. I think this is a few months after I started my own company, TFO. And I remember that some colleagues in the community suggested me, why not propose the presentation for AosCon, which is our most first-class friend in open source community. When I receive or open that email, it was 3 days after the deadline. So I replied to that person, sorry, I missed the deadline. He came back, maybe you can make it. So I sent email to steering committees of AosCon, and they also kind of excited to have large-scale software built based on ROS. So this AosCon 2016 was a significant moment that we presented Autoware to the open source community. I'm sure that this moment accelerated the development of Autoware, and more people start having interest in Autoware. Now, at that time, Autoware was just a software project, which was led by a few companies. Now we decided to launch the Autoware Foundation because I strongly believe that true open source project shouldn't belong to a particular private companies. It should belong to the communities. But communities need some organization who can manage the bunch of tasks. So we decided to launch nonprofit organization, the Autoware Foundation. Next. Autoware Foundation was lucky in the sense that when we started this organization, many other organizations approached us, hey, let's work together. So that's also strong point of open source. When you start in community, there are already other friends hoping to work together. On the other hand, if you start your new company, startup, you'd have more difficult moment because you need to compete with your even with your friends. But open source, it's no competition, it's all collaborations. Now we created the foundation. And can you go next? Then we started having a casual meetup. The first meetup was in Silicon Valley, as far as I remember. But at some point of time, we had the meetup with founding members in Tokyo. And since Autoware, was origin in Japan, so this meetup was also kind of significant timeline for us. And even today, I think still many contributions coming from Japan. I don't know in global market how Japan is recognized, but I think that Japan is not leading in technology and industry today. We're still good, but we are not the number one. However, if you start open source project, I think Japan is not a bad place at all. I think it could be one of the best places to start open source project. I want to tell the government that startup ecosystem still, of course, good, but maybe Japan could be the leading country in open source. So please stay tuned. I think we can further accelerate Autoware Foundation with other stakeholders like government or even individuals. But today, I highly appreciate mostly enterprise companies. They contribute a lot to the growth of Autoware Foundation. Can you go next? Recently, so we distributed because region by region, the objectives of kind of accelerate open source project is different. Taiwan was the first region that we founded a new chapter where the local companies can communicate more in depth. Global, global community, yes, is very strong, but sometimes we're struggling in communications, time differences, different languages. However, local communities, the scope of the communication may be limited, but it is more efficient because you can speak your mother tongue. Also, no time differences and physically close places. So we like to facilitate more local communities. So following Taiwan, we created Korean communities, and we're trying to create US, China, and Europe regions. And each region has different regulation, different policy. So I appreciate, the whole operation, effort in the foundation. They expand the contributions of this foundation and Autoware globally. Last year, it was also nice to see this award. So you saw the few slides, but before the few slides, I presented, the first moment that we presented the Autoware in ROSCON. Now, last year, the ROS community selected Autoware as one of the best contributions using Autoware, ROS. Yeah, Ross and Autoware, I think we always together, and I think we can grow more in a sense that robotics, car industries, I think they will use open source more because say AI-oriented system or robotics-oriented system is very expensive to build from scratch, standalone. So using open source, you can skip the baseline development, and Ross Autoware could contribute a great deal to those initiatives. And yesterday, this is also fantastic to first showcase Autoware in IAA, which is one of the largest scale conference for mobility. And these people come from the World Economic Forum. So the World Economic Forum is now supporting us. If you look at the report from the World Economic Forum, the future software-defined vehicles or future autonomous vehicles will leverage the power of open source. So it's not just about us. The world economics is now looking for the use of open source for the future software-defined vehicles and autonomous vehicles. And this demonstration was provided by TU Munich, one of also the greatest contributions in Autoware. Unfortunately, I was not yet on this test vehicle, but I know that many other colleagues had a test drive with this vehicle, and it's all great experience. I feel that was all great experiences. This is power of open source. Somewhere you don't know, it happens. In Germany, a university is building autonomous vehicle using open source. Then one of the top communities in economics, the World Economic Forum, now seeing this as a reality. So I want to make it happen more and more. So I highly appreciate your further contributions to Autoware. And if you need support from the communities, please also do not hesitate to ask us. We are not sure how much we can support that initiative, but at least we like to support as many partners as possible. So thank you very much today for coming on site, and many others seeing this online. Thank you.
To those here in the conference room, Kato-san will be joining the social event after the session from 6 o'clock. So please come to the networking event and talk to him in person. All right, so let's shift gear to the strategic discussion. We'd like to spend the next 20 minutes talking about the strategic initiatives that the Auto Foundation and the Auto community is going to make. And Steve Taylor, who is in Cambridge, the UK, and also the key leadership of SPC, will talk about some of the insights and early preliminary study result that he made to derive best practices and there should be a way forward for the Autoware Foundation. So good morning, Steve. Are you there?
Good morning. Yep. Can you hear me
Over
okay?
to you.
Thank you very much. I'll just try and bring. That should be working. Okay. I'd first of all like to thank everyone who's already presented today, and particular thanks to Kato-san, not just for your keynote. And I'm very happy that I'm not repeating anything you said there, but I hopefully complement and supplemented a little bit. And also thank you so much for starting Autoware. I'm Steve Taylor, as Tanaka-san just said, responsible for developing growth strategies at the Autoware Foundation. We're at an inflection point in autonomy. Closed and open systems have driven autonomy progress to date, but open ecosystems will define scale. Exactly what Kato-san just said about the World Economic Forum highlighting this. And Autoware 2.0 is our opportunity to make that happen. We'll start with a little history, then look at today's progress and end with our community. As early as 800 BC, autonomous tripods appeared in Homer's Iliad, and Da Vinci created a self-propelled cart 500 years ago. But the modern era of powered, driverless vehicles appears to have begun 100 years ago with Houdina's radio-controlled car and an accident reported in New York. These are photographs from the original magazine from that time. Since then, we've seen GM, RCA Labs, and Ohio State build on the Houdina concept. And then Tsukuba, Stanford, Carnegie Mellon, Eureka Prometheus, and DARPA begin to encourage digital control. Now we're seeing many people educated in those later programs pushing the rapid rise in developments today. A bit of more recent history. For the last 20 years, many of the developments have been caught on YouTube. These developments also include Autoware, and I couldn't resist sharing a screenshot of a Nagoya University car being presented by Kato-san just over 10 years ago. This was posted on 25th of August, 2015. And of course, Kato-san was hands-off in the driving seat. I'd encourage you all to find that video and like it. I found this because I've discovered that YouTube can be used to visualize the hype cycle of recent autonomous developments. This chart captures a daily load of over 38,000 YouTube videos posted about autonomy since 2006. Shortly after YouTube started. These videos represent billions of views and have been loaded from over 12,000 accounts. You'll note that the Autoware Foundation started just as peak interest began to develop. You can see that this year, an average of almost 20 videos is loaded every day. And when I updated this data this morning, there were 40 videos posted yesterday, double the year's daily average. 4 have already been posted today, and this AutowareCon video and many others should join them later, along with the videos from IAA Mobility and the TUM Edgar vehicle. The videos go back to the DARPA activities, and the massive promises and inflated hype, which ran up to around 2018. Technical reality, a fatal clash, and some levels of disillusionment in financing and activity then set in. This was amplified by the arrival of COVID, but the last couple of years has seen an explosion in new solutions and deployment, on-road and off-road. We've passed the peak in hype, and we are now clearly moving to scaled adoption. One major question is whether the future is all going to be up and to the right. The software market for autonomous vehicles is incredibly busy. there are many different solutions, some completely proprietary, some with open source elements, and some based largely on open platforms. There have also been some casualties falling by the wayside. As we move forward, we can unfortunately expect more companies dropping out, as happened in mobiles and servers. The mobile and server markets began differently, and players grew with the market until Apple and Google took over mobile, and data centers have focused on Linux and Windows Server. Both of these are now $500 billion markets with essentially two software players, both enabling different types of ecosystems with very different levels of flexibility, but massive scale. An open source platform dominates both Linux and Android. When the AV market reaches that scale, how many software platform players will remain? And will the majority of the revenue generation be in services built on and around the platforms, or the platforms themselves? And will that revenue be funding the maintenance of the underlying platforms or the services? History would suggest it won't be the platforms. For mobiles and servers, legislation has also been chasing the technology and has not managed to catch up in many areas: energy consumption, personal data sharing, accessibility, cost control, and many more. Autonomous vehicles on the road are very different. They have been moving into a highly regulated environment that has been designed around human drivers with adaptations for other road users like pedestrians and cyclists. As technology has advanced, the promises of improving accessibility, reducing emissions, tackling driver shortages, and improving safety for all, plus the potential business revenue boosts expected, are persuading governments to get the legislation ready to allow the trial deployments and move into full availability. The OECD International Transport Forum is working with 54 countries, and many cities and states are also getting involved, with legislation now charting the way from today's ADAS functions to full driverless autonomy. While legislation has been applying the brakes for both proprietary and open source autonomous solutions, governments are encouraging developments with significant funding and many public-private partnerships driving innovation. This is not just on the roads, but at airports, ports, campuses, and many more locations. With many funding programs developing this year, with some focused on this year and others on this and the next couple of years, it looks like about 35 billion is being committed by governments around the world to accelerate AV developments. How much of this will go to developing proprietary solutions with limited benefits to others, if the agreement and mechanisms to share data are not in place? And how much will go to open source projects with the results shared for all? It's very obvious why the World Economic Forum is interested in openness. In the bottom left, I show a chart from Oliver Wyman showing global mobility funding per year from the beginning of this year, so from about January of this year. That report talks about a pickup in 2025 funding to 54 billion, with a focus on companies reaching commercial scale with tried and tested technology. Autoware has many proof points that can be used by our members to show the pedigree of the technology. So we welcome everyone to contact us if you need help in this area. Today's legislation applying the brakes and funding encouraging developments is like applying the brake and accelerator at the same time to take a fast corner. As the brakes come off, who is going to forge ahead? Open source allows standards, trust, and safety all to be developed openly. It makes technology more scalable by allowing more talent to work together on the fundamentals that vendors can then build their differentiation and profit on. It means wheels only need to be invented once and can then be used and developed by all. And Autoware has the opportunity to do for autonomy what Android and Linux have done for mobile and servers. Android generates about 10 billion annually for Google just via the Play Store, according to 2025 estimates. It's unclear how many engineers in and outside of Google are working on Android, but it's a large number. This chart shows the monthly revenues of some non-profit open source organizations from ProPublica in the US. It's a logarithmic scale, so the top blue line shows the Linux Foundation generating hundreds of millions in annual revenues, over 10 million per month, from memberships, events, training, and more. The Mozilla Foundation is in orange, and this shows the revenue for the foundation, for which the profit-based Mozilla Corporation is a wholly owned subsidiary, generating about 3 times the revenue of a non-profit parent. OSRF is also here in green, and the drop in its revenues in 2023 will then when the for-profit subsidiary of OSRF was acquired by Alphabet subsidiary Intrinsic. I've also included the Open Compute Platform in yellow and the Eclipse Foundation in red, and it'll be interesting to see how that line for the Eclipse Foundation grows with the recently announced activities around S-Core with Mercedes and other partners. There are many lessons to be learnt from a past experience of others, and I hope one day we can share the Autoware Foundation's position on this type of chart. Autoware is already deploying worldwide in multiple application space, and we've seen some of these earlier today. As we release Autoware under an Apache 2 license, we don't know all the deployments that may be using our code, but we'd encourage anyone who has used Autoware in the past or is using the latest code today to get in touch. We'd love to shout about what everyone is doing with Autoware, but we understand that not everyone wants to do that. Many want to operate under the radar. And so we have various engagement models in which we can provide direct project support confidentially and still enable companies to reap the benefits of collaborative development. And apologies to all for the tiny logos. One of the results of the success of the Autoware Foundation. And many of you may have seen our announcement of exceeding the 100-member mark. And you probably know something about the range of members and partners that we are now working with, from associations like ASAM and SOFI, through middleware and OSs to chips, vehicle OEMs and tier ones, and of course, many universities. Clearly, a lot of our activity is on delivering the technical side, and I hope you've seen compelling evidence of that in today's presentations. But this invariably extends into other areas like safety and regulations. There are also opportunities to collaborate on seeking funding and promoting adoption in society with education of many types. Autoware is at the heart of this collaboration. As we approach the end of today, I hope you will all be thinking about the opportunities to collaborate with Autoware and help shape the future of autonomy. Many of you may be developers, but there is room for lots of different contributions from all types of people and organizations in delivering on the Autoware mission and vision. Building open source software for globally trusted autonomous driving systems that engage and advance society by co-creating a neutral, trusted hub that advances safety and beyond in mobility and society. Thank you for your time. please don't hesitate to reach out to discuss shaping the future of autonomy together. And don't forget, we're building code, collaboration, education, identity, and culture too. And Summit asked me to point out that the Autoware mascot on the right is a work in progress, currently under development. And obviously, the links here will be available online for people to follow up later. Thank you very much.
Hi, Steve. Can you stop the screen sharing on your end?
Oh, yes, certainly. Sorry. Let me just
no.
do that. There we go.
Okay. We have one more agenda, which is about deployment successful stories. In this agenda, we will have a live streaming session from Munich. But first, we want to start from Nakayama-san's presentation around Tier 4's deployment story.
Hi, good afternoon and good evening and good morning, everyone. I'm very happy to hear this remarkable day to speak with you. And today I'd like to introduce the decades of Tier 4's deployment in terms of the autonomous driving software. So let me start my self-introduction. So I'm Yusuke from Tier 4. I'm in charge of the head of global business. So I'm coming from a business side. And then I'm started my career for 20 years before for mobile phone engineers. So I remember that time that was a market was completely different from these days. So this mobile phone industry has completely dominated by the giants, so kind of like Symbian OS or Microsoft OS, Windows OS. So, but all you know, the situation has completely changed. So as my first career, I have an opportunity to work with an Android open source community. So I work with community and develop multiple Asian global Android devices with them. So from this experience, I feel that the power of the open source. So next slide, please. So then I'm jumped into the autonomous driving industry for around 2018. So this history is expressed at almost decades of Tier 4's history, and I know that many of the history is shared by the Autoware foundations. So I have experienced a lot of the deployment project inside Tier 4. So we took the approach to collaborating with various kinds of ecosystem or business partners like manufacturing companies or transportation providers, municipalities, or site owners. So next slide, please. Okay. So yeah, as of today, Tier 4 has deployed, I think, roughly more than 160 projects across Japan. And then half of this project, I can say that it is already commercial. So commercial means that it is paid by end users and working right now somewhere, and they are replacing the human works previously. Okay, next slide. Yeah, so I can say that we deploy a lot of vehicles. So it means that we provide the possibility to the existing vehicle. We unlock the AI autonomous driving possibility to the existing vehicles, right? So of course, our software stack is built on top of the open source software. So it means Autoware, but we providing to the customer, so validated software as a service. So I feel like these days of autonomous driving industry is coming, how can I say, the second wave is coming. So first wave, I think that it is started around 2015. It is all about demonstrations. So many people want to see the autonomous driving vehicle, but their purpose is, how the software is work and drive the vehicle. Yeah, just a demonstration. But nowadays, the situation is gradually changed. So many people wanted to know, is the autonomous driving technology can replace the human work? Is it useful for human society or not? So in that such case, more business partners wanted to involve this business ecosystem. So they wanted to have access to the core technologies. So the transparency is a key competence for us. And the other one is business partners wanted to build their own business. They wanted to add their own value on top of the ecosystem or our platform. Yep. Then I can share some experience of my hundreds of deployments. So I would like to share the 3 key points for the to the barrier or to accelerate the deployment. So first one is a data reduction. So data is, of course, it is very important. So only the data can express a lot of things. So end users encounter the autonomous driving, they want to know what is happened and how it doesn't work. So that only the data can express a lot of things. But data itself, it's put pressure to the business structure. So if we can reduce the data itself, the business will be accelerated. The other one is a document, right? So document sounds like a little bit boring. But if you go to some website like Linux Foundation or Android open source community, so I think that in top is a video. You can see the videos. Hey, welcome to the community, and what do you want? What do you want to do? And if we want to build your business, let's come to this material. So document is a kind of the navigation. So if we want to involve a more ecosystem or business partners in our business on our ecosystem, we want to express a lot more than the source code. Okay, the last one is an interface. So as I said, more and more partners want to build their own business. They want to make money around our ecosystem or our platform. So if the interface is not guaranteed, their business or just their system will be unstable. So if this interface is guaranteed, we make them the confidence. Okay, finally, but anyway, there is a lot of, I know the barriers existed. So poor functionality or low quality will be a barrier for the deployment, but I think it is not a main problem. So we wanted to move forward. So although many of our project is deployed across Japan, we keep moving, but we also looking for the global opportunities. So we have started deployment of public transit or off-highway automation opportunity, like we're starting with the factory automation, and then we are moving gradually to the construction or something. So if you wanted to work with Tier 4 in globally, so please feel free to contact me. Yeah, thank you so much.
Thank you very much for the very interesting presentation. I was wondering if there are any audiences from the question or on Zoom. Well, I have a question that I wanted to ask you. So you've seen the journey in Android and the development, and we all agree that open source is the future. Are there any areas that you are personally most excited about? Any use cases or applications of open source autonomy?
Your question is, you want to know some use case of open source?
Yeah, that you're most interested in, that you think will be very exciting.
Yep, there is, of course, a lot of use cases that existed. So many of my experience is coming from the factory automation in autonomy. So I feel like how can I say, the capability of the software and our product would be can say that overcome the human the end user's requirement sometime. So in that such cross point, so I'm very interested in. So these days is a factory automation or just a public transit, but I think gradually the capability of software or product would be gradually improved. So I think there's a lot of interesting use cases like constructive automation or something like that.
Great, thank you very much. Round of applause, please. Just one moment. So our next presentation is from Samit Kutuk. So pass over to you, Samit.
Thank you very much, Zain. Hi, everyone. For people who don't know who I am, I'm Samit Kutuk. I'm a community advocate and the head of marketing at Autoware Foundation. And today we are at IAA Mobility in Munich. And I have CJ from Tier 4 and Autoware Foundation with me. Hi, everyone. Hi, CJ. And I have also Dominic. I have Marvin. I have Corbinian. So we are going to take you for a ride with Tom Edgar. We are not going to take so much time. Also, we are on a schedule. Their rides are fully booked, so we don't want to skew their schedule. But I want to start by just giving a quick tour around the Tom Edgar vehicle. As you can see, we are between Hall 2 and Hall A2 and A3. And they've been getting these autonomous rides, for the entirety of the IAA mobility. This vehicle is retrofitted with all kinds of sensors. There's a safety operator behind the steering wheel, but we are going to get on a 40 minutes autonomous ride in and around Munich, including urban area, highway stretches. So that's how the Tom Edgar vehicle looks like. We invite you to take a ride wherever you're in Munich. Get in touch with the TUM guys. And I'm going to be joined in this ride with Dominic and CJ. So let's get in and see how it is. Okay. Right. Dominic, how many rides did you get already?
Already, I think on Monday there were press rides, something like, so we were fully booked, but a little bit under 10. And yesterday we had about 20 people here, so fully booked the whole week.
They were quite happy about that. It's a lot of interest.
Let me just hook myself up. Yeah, we're set. Dominic will talk to us also, during the ride. We are just going to, first of all, to start things with, they are not allowed to drive autonomously in the IAA mobility grounds in the Messe fair area. So we are just going to drive out of the gates and then they are going to engage the autonomous driving and we will start our journey. So let's maybe not like that.
Also interesting for me, it's the first time in the back seat actually of Edgar.
Okay.
The other times I'm sitting on the left or right side on the front. It's also a new experience for me.
Yeah. We did the Autoware Cafe together to promote and talk about this activity. It's nice to sit next to each other and yeah. Did you guys have any glitches or anything like that during any of the previous rides?
Actually, we have had some issues with our interfaces from the vehicle itself, but no major worries, I would say. Such normal things for a research vehicle.
Right, sure. When we engage, if you let me know, I'm just going to switch camera to the front camera.
Yeah, we just drive manually out there. You actually need to show your passes.
Right. Okay.
In just 1 second.
This. Thank you.
All right.
All right. I think we are about to start soon, so I'm just going to.
You guys had officials from the government take test rides yesterday, and how was the response there?
Yeah, great. So yesterday we had the Minister of Education here with us, and so Staatsminister Blume, and it was a great ride. He was quite satisfied what the German universities, especially TUM, can do. And now we're actually autonomous, fully autonomous.
Now we are on the autonomous mode.
So Marvin will just keep his hands very close to the wheel as the regulations, or the regulators told us, because that's what we have to do. And on the right side, I don't know if you can see, there's Corbinian is watching the software, all those modules on the laptop, and is just looking if there are any
or not.
Yeah, right.
It's driving quite a decent speed. Oh, there's a bus coming up. Yeah. It's fortunate that today is not raining. Yesterday there was a concern, right? If heavy rains or whatever, but
yeah, unfortunately, our regulations don't allow us to drive on heavy rains or in bad weather conditions. And also we have to see, currently on the software stack isn't the best in all adverse weather conditions. So we definitely would hope that the weather stays good today. I mean, just some small raindrops as of today, it's perfectly fine for us.
That shouldn't bother it.
Do you have a timeline when you think you'll start to be able to drive in more adverse weather conditions?
I think one of the major advantages of radar is to drive in adverse conditions, and we are trying to integrate more and more. But currently, we are heavily based on LiDAR and camera system. And actually, we see also, for example, so we could definitely improve on the object detection system and localization, but there are some modules which just requires cameras. For example, the traffic light detection. We see if we have raindrops right on our lenses, we cannot, or we have a hard time detect the actual state. So there, I think we would actually need some hardware modifications to have always a clear vision.
Warn us if we are going over time. We don't want to, skew the schedule of AutowareCon either. Do we expect any interesting, use cases along the route?
Yeah, currently here it's like from calm. We will be in like 30 seconds if we have like a green traffic light up front, be on the highway. So we go up to 100 kilometers per hour and drive there for a few minutes on the highway.
and then come back to more of a inner city driving, and yeah, coming just back from where we started.
Very good. Yeah. So I think that's all us. That's all from us. But we are going to record this right also, and we are going to make this available. That's it from us. So have fun at AutowareCon for everybody joining in person and on Zoom. See you later.
See ya. Bye, everyone.
Bye.
Thank you so much, Samit. I think he's still there. Looks like a very smooth and nice ride, and jealous that I couldn't be there. But I'm glad to be here as well. So next we have a presentation from Nagoya University, Kenta Urano. So a round of applause, please. Welcome to the stage.
Okay, let me start my presentation. So the title is, as you can see, I did the real world experiment in Japanese mountain with Forestry folder. Next, please. Okay, so let me start with my background. So this is about the forestry. So in Japan, the forestry is considered as hard labor. So it's so-called 3K. It's the word from kitsui, hard, kitanai, dirty, and kiken, dangerous. So because of that, we need to be efficient in forestry. So we have to cut out the wood and then load the wood onto the truck or other machines. But because this is AutowareCon, we can automate that process. So next please. This is the process of the raw cut out work. So first we have to cut out the wood and then load onto the forwarder. The forwarder is big like that, and it has a grapple, and it can grab the wood and load onto that. And someone has to drive the forwarder to the unload place, and then the other truck will carry the wood. And so step 2 and 3 can be automated. So the grapple automation was work for other research foundation, but for the automation is our work. And we also collaborated Map4 and for map creation. Before starting the big setup, this is the real site of the automation located in Gunma Prefecture in Japan. So actually it's in mountain, and road is unpaved, and it has a slope, and total road length is about 300 meters, and there's a vehicle we have to automate. So the next, please. So actually Map4 did the scanning of the forest, and this is a map of the rare site. So the purple highlight is already vanished, but the purple highlight was the load, and it's about from start to end, it has a gradual right turn, and the length is about 300 meters. Okay, next, please. So this is for the sensor setup. We installed Panda 40P LiDAR and tag 300 IMU for the location estimation. Actually, it's loaded onto the top. The caption is not right, but it's on top. And we also installed the wireless IMU into the forwarder's crawler to detect the crawler movement. And also for obstacle detection, we also installed the Panda QT 64 sensor at the front. Next, please. Okay, and because the forwarder is not equipped with a CAN interface or no throttle, brake pedals, or even without steering wheel, because the completely different control system. So for that, we made some ROS nodes to get the odometry information or steering information from the forwarder and to control the forwarder by the software. The next, please. So this is the first footage of the first successful forward movement. So actually this rod is the control system for the forwarder, and there's no driver for now. So at first it was 40 meters for autonomous driving, but later we need to do more longer and difficult roads. Okay, and next, please. Okay, the first experiment was about 40 meters, and the road was very wide, about 4 meters. But the road gets narrower and narrower afterwards, and I think the road length is about 2.5 meters, whereas the forwarder is about 2 meters wide. Okay, so the next, please. So this is the footage of the longer driving. So the whole road, 350 meters, and without no interruption. And now the video is about 8 times faster from the real speed. So but can you see the further goes left and then turn gradually to right, left, turn, left, turn, left, turn. So it doesn't follow the Autoware's path at first. So but somehow it completed 350 meters. So because the left side is mountain, so because of that, going left is no problem. But if it goes right, it falls into the valley. So next, please. So actually the password like that. So and after some investigation, we found that the voltage generation for vehicle control was buggy, and finally we did this kind of. Okay, next, please. It's downwheel situation from the opposite direction. So that if in this situation there's no room for going left, because I think it was 20 centimeters from the left end. So but this time this is very fluent following of the path and no problem, no interruption for the autonomous driving. So but this is, I think this was the 3-day experiment, and this was the final day of the experiment after some modification of the programs. Okay, this concludes my presentation. Thank you.
Thank you very much for the very interesting demonstration. And I think this is a very, very cool application. So are there any questions from the audience? Yes, hand shoots right up. Yeah.
Excellent presentation, very interesting. Just one question. for the extension of this work, for example, for the business of forestry, I guess one of the needs in order for you to deploy the truck and the vehicle is to have prior maps. So do you see, say, this can be continued to or extended to other fields, for example, where there is not a very clear road to follow, or is it in a way that you are considering, for example, for mapless navigation in order to achieve these kind of tasks?
Okay, so this was the this was a research project in Nagoya University under other agency, and the map for the scanning company was in the project, and we just used the plain Autoware setup for using the point cloud map and the normal Autoware's map system. But the other researcher is trying on to detect the runnable road from the camera's image. So it can be converted into mapless situation, but currently we don't consider the mapless situation. But in the future it can be.
Thank you.
Any other questions? In that case, thank you very much. A round of applause, please. And the next presentation is from Jorrit Kuipers from Columbus.
Hello, good afternoon.
Good afternoon. Over to you, Jorrit.
Very good. First of all, many congratulations to the Autoware Foundation with the 10th anniversary and all what is already achieved, and what we can use. And I will try to share my screen. Is it visible?
Are we able to see your screen?
I cannot hear the comment.
Sorry. Hey, Jared, we're able to.
Okay, thanks.
Yeah, thank you.
So, today, thanks very much that we can present our initiative in the Netherlands. We are setting up a learning community for autonomous transport of people and goods that we called Columbus. So the focus is public transport. And already a lot of parties are involved, but the main contributors to this project are the Metropole region, Rotterdam, The Hague, and the province of Groningen. And parties working with us like Qbus, it's a public transporter and it's owned by Bus Italia or the Railway Italia and the University of Groningen. Let's see how I can go through the slides. Yeah, so I'm owner of two companies, RobotTuner and Green Dino. And RobotTuner is one of the main contributors to this project. And to give you an idea, we established Green Dino in 1992. We're focusing on the automation of training and testing for human drivers. So our background is not in technology, but in training of human drivers. And because we do it automatically, we collected a lot of data. So we have data of more than 300,000 human drivers. And we use this data also to build reference models for good performance driving styles. In 2016, we established RobotTuner with the idea to focus also on assessment of the behavior of autonomous vehicles. And at that moment, they couldn't do so much in traffic. So we offered our clients, the provinces, to build a system ourselves with the knowledge we already had in the driving simulators. And in 2022, we thought that it would be necessary to start a national initiative using the open source software Autoware. To give you an idea about what we did with Green Dino, I have a short movie about our driving simulators, a bus simulator. So we're now here in the bus simulator. It's used for the training of professional truck and bus drivers. And here you can see that we also have built a metric system in the bus simulator. So it calculates the risk someone adds to the traffic situation. So now I'm driving away from the vehicles and the risk becomes less. And we record all those things. So on the timeline, you see red spots, and those are safety critical situations. So we have this complete simulator environment, but also the data about human performance. And we follow the human drivers on the road. So we know their accident involvement, and we correlate this information with the simulator data. We have now respondents of drivers. I'm writing a paper with 3,000 respondents who already had more than 10 years the driving license, and we still can compare the data coming out of the questionnaires with the driving simulator data. So our mission with Columbus is to enhance the capacity of transportation using Autoware. So we're really focusing on Autoware. New members also should use Autoware and enlarge the capacity in the Netherlands working with Autoware. We especially looking to tune it for the Netherlands so that it is fulfilling the requirements that come from our vehicle authority and from our driving license authority and the Dutch traffic situation. So here you can see some of the equipment we use. We try to use low-cost controls and sensors to keep the cost as low as possible, because that is one of the problems, is that we have to increase the capacity, but there is not much money in the market to pay for this automation or new vehicles. So we make an autopilot kit that can automate the existing fleet. And we're focusing on the bus depot, so it should be very low cost of price. Here you can see that we use the drive-by-wire technology that is already in use for handicapped people in cars. And we were able to apply it to buses and drive the buses with this equipment. We did before the summer, a demonstration on the ITS Sevilla, and I have a movie, I think. Yeah. So this is really a proof of concept, and we are now in the phase of going to the bus depot and also add extra functionality to the system, but also make the system that we prototyped more production ready. So that's the target for 2026, working together with QBus and the province of Groningen. We have subsidies to do this. And then in 2027, go to dedicated bus lanes, less complex ODDs, also the bus depot driving at very low speed. Local sensors are already enough to be safe. And then at the end, trying to go to commercial use of the autopilot kit in buses in public space, so on every bus line. So we also used Autoware already into student challenges. Our vehicle authority has a student challenge for the whole Netherlands for different teams. And in 2024 and 2025, we supplied a Renault Twizy working on Autoware. And the University of Groningen is now preparing for 2026, also using Autoware and trying the students, let them use Autoware to do the trajectory with traffic lights, turning, etc., etc. So this is also a very nice way to use Autoware and make students familiar with the Autoware community and software. Next to the large buses, we're also looking at very tiny buses, the microbuses, and we are developing a retrofit multi-purpose vehicle. And what we here see is with a docking for drones, where we try to make a sort of research and development vehicle with exchangeable modules. At the back of here we have a module with 2 places for seating. And especially such kinds of vehicles could be interesting for inner city environments, working overnight, going to the front door and then to the bus stop, because the large vehicles cannot collect people from home, but such multi-purpose vehicles would be able to do it. So that's another project that we are working on, and also using the same Autoware stack. So this is a bit of an overview of our architecture. What we're trying to do is not only to steer vehicles, but also gather data and assess the vehicles and make a certification, autonomous certification process for it. So we are trying to reconstruct the ODD using the sensor data and loading it up to a synchronized digital twin, not only to assess the autonomous driver, but also the human driver, so that we can use the hardware that we use on the bus depot also during normal driving of a bus driver. Then the hardware is not connected. We call it shadow driving, but the autopilot, Autoware, can give feedback to the driver in case of near collision problems. So, and this is also very important to see what we build. We can do the simulation testing, human in the loop testing, but also collect the data and do the validation of what is developed before the vehicle is applied on the road. So this was my presentation. Thank you very much. And maybe there are some questions, and otherwise you can get more information on our website.
Thank you very much for the very interesting presentation about Columbus, Jorrit. Any questions from the audience or on Zoom? Yes, we have a question here in the audience.
So I think in one of your earlier slides, you mentioned about tuning Autoware for Netherlands. So I was wondering if you can give an example of what kind of tuning that you had to do, or if you still haven't solved the issue, do you have any kind of challenges in your mind that is particular to Netherlands?
Yeah, one of the things that we discovered is that we use now a very large bus, and it's responding very direct. So if, for example, the back of the vehicle is not in the path, it tries to compensate in front, but driving out of the path, doing things that we think that are dangerous. So we're really going now into how, for example, the planning module reacts. And it's also depending on, for example, we record routes ourselves driving the bus, and we want to follow the bus, the specific steps in the route. So that's a bit of a different than doing real-time planning. We already have routes. So also, yeah, you have specific ways of how to react on bicyclists. We have a lot of bicyclists in the Netherlands. For example, when the deviation distance with a bicycle is not so large, after passing the bicyclist, you should not directly turn to the left. Or if you deviate, you should first look in behind you if you're not overtaking. So I see a lot of videos where still the planner module is too direct. So we have a lot of time to go back to our own desired lane. And I still see very reactive behavior also with braking. So those are things that we have to go into, how the planner works and see if it is the same way that we record how the Dutch drivers and other traffic behaves.
Great, thank you. Thank you for answering.
I also just wanted to say that I think with the new Learn planners, all of those nuances can be learned based on human-driven examples. So all of the things you mentioned are some of the motivations about why we want to introduce end-to-end AI-based technologies, just so you can get those nuanced behaviors, understanding the local versions of driving, because you can fine-tune that Learn planner on your specific data for your specific route even, and have those kind of intricate kind of human dynamics learned inside the stack itself.
Yeah. Yeah, but what is very important that it's transparent. If something happened, we should be able to trace back how the system made those decisions. So we're really relating on procedures. So humans are learning driving, following driving procedures. And having those driving procedures, you have the algorithms to verify your data. So our whole system is based on procedural algorithms.
Mm-hmm. Yeah, well, I think it's a very exciting space, and very, very pleased to see the great work that you're doing. And thank you for taking the time to present. Thank you.
Okay, bye-bye.
And our next presentation is from Virtual Vehicle, Marcus Schratter.
Hello, everyone. Can you hear me?
Yes, we can hear you, Marcus. Over to you.
Perfect. Then I'm going to share my screen. So, can you see it?
Yeah, we're able
So,
to see your
hello
screen.
from my side. So, my name is Markus Schratter. I'm from Virtual Vehicle Research. We are a research institute company located in Austria, Europe, and our main focus is research in the field of automotive rail. So this is what we did, let's say, the last 20 years. But also like the last 5 years, we also extended our domain. So at the moment, we're also working in the field of aerospace, logistics, energy, healthcare, defense, maritime. And for this kind of areas, we have different demonstrators. We are also working together with different partners. So we working strongly together with the automotive industry, so with the OEMs, but also with suppliers. And on the other hand, we are also working together with different universities, other research institutes. So we are bridging a bit the gap between research and industry. So this is our main focus of our research company. We have different shareholders and we are about 300 employees at Virtual Vehicle. So, like I mentioned before, we have different kinds of demonstrators, and over the last years, we developed different solutions that we can fulfill different driving tasks which are requested from partners, other companies, but also from internal requests. So we have a quite flexible hardware and software solution, which is working in simulation, but also we can use our different demonstrators on the real world. And the most of them are operated with Autoware. So we are starting using Autoware 2018. So we are using Autoware, let's say, quite long. And so far we deployed it to different platforms. So all the platforms which you're seeing here now, they are using Autoware. So we have passenger vehicles, we have a UGV, but also we deployed Autoware to a bus. We also used some parts of Autoware in history at RoboRace. So as an example there, we used the NDT localization. And then we have a quadruped robot. About that a bit later more. We are also at the moment integrating an Autoware interface to drones. And we have demonstrators in the field of maritime. And also over the years, we developed different kinds of sensing platforms depending on the use case. So let's go back to automotive. So we have different passenger vehicles, and similar to Edgar, we're also able to use them on public roads in Austria. So we can fulfill level 4 driving functionalities on regions where we have put the permission in Austria to drive. And like I mentioned before, so there we are using Autoware Universe. Also, our vehicles are using normal automotive sensors, so SLB sensors. And at the moment, we provide interfaces to about 20-25 different kinds of sensors. And like our architecture, it's quite open, so we are using ROS. So if a partner would like to integrate a software component, or we should test the software component from a partner, we can easily do this because of this, let's say, quite open interface. And also, like, our vehicles are used for different research projects. So we providing then with our demonstrators then an automated driving platform, and different software functionalities then are replaced, as an example. And also we integrated the Autoware stack together with other partners on different vehicle platforms. So like you already see, we have a lot of different demonstrators, and to make it not too complicated, we try to use all the time the same Autoware stack, of course, with different modifications. So what we're doing is for each vehicle, we have a sensor launch, which fulfills the sensor setup of the platform. So each platform provides the same data format. And the same is what we're having for the vehicle interfaces. So we wrote some nodes which are getting commands from Autoware and reporting to Autoware what's needed. And then our components then sending via CAN, as an example, to the vehicles, or via UDP to the quadruped robot the command. So there we have a quite flexible interface that in the middle, the software stack is more or less all the time the same. So we built up some vehicles. So we started 2017 with Ford Mondeo. And here on the image, you can see the car. So we did all the modifications in-house. So all the electrical, mechanical, software integrations are done by ourselves. So also this makes a huge advantage that we know each component quite well, and we also can modify any kind of hardware or software part. And like I mentioned before, we have also permission to drive on public roads. So this is a short video. This is from the last year where we drove in Wörgl in Tyrol. So there we have permission to drive up to 50 kph. What's there, the speed limit? We can also drive there during bad weather conditions. And on the left at the top, you can see the camera image. Below, GNSS looks at this part quite well because we have open sky. And on the right, you can see what we see with the LiDAR, so how the localization is working, but also what the planner is doing. And this part is quite interesting for us because you will see here a quite narrow tunnel is approaching. So the width of the tunnel is 5.5 meters. So this means gap between window and wall, it's around 10-15 centimeters. And it's very impressive to see how well the localization, planning, and control is working in the tunnel. And also, like you see here, oncoming traffic is no issue. And when we are out of the tunnel, then we have, again, a good GNSS localization, but like we are using LiDAR localization, so this is not really an issue in that case. So quite impressive also for us to see how well Autoware developed over the last 10 years. Another vehicle platform is our 01, a bit of a different type of car. So like you can see, no steering wheel, this is the big difference. And also we just have one LiDAR, one camera, so it's more, let's say, a limited driving platform, so we don't have permission to drive on public roads, but we also can drive with Autoware on restricted areas. And at the moment, we are also building up together with Alplab a bus. So the bus is manufactured by Eversum. And we, as virtual vehicle, we are integrating there the Autoware software stack. We also did the sensor concept. And here, as an example, you can see a short video where we are driving with the bus at the bus garage of the local transport company. So we have there a small road network. We defined some bus stops. And there we did our first automated test with some passengers from the company. So it's a quite new video. And also, like when the bus is reaching the bus stop, the door is opening automatically. Also, you can see the bus is going down, that the person can go out easier. And also via ROS2 service, we are able to control the ramp. So we can go out with the ramp if there is a wheelchair driver. But in this case, you can see a colleague, Markus Postel, who is responsible for the software integrations. He's, in that case, walking out of the bus. And another platform is the Spider UGV, a quite universal platform. So what we can do is we can rotate all 4 wheels individually. And this makes it quite useful for different kind of tests. So what we can do with this platform is we can do sensor tests, light tests, and all of them are all the time the same. So this is a very reproducible platform where we drive automated. And also this platform is used for research and rescue projects. As an example, you can see at the right bottom, there we are driving automated also with the Autoware stack in a tunnel in Austria to monitor if there are somewhere, as an example, pedestrians. And the final demonstrator, what I would like to show to you today is our quad-roped robot. So it's a Unitree Go 1 and a very reduced sensor setup we have there. So there's just one LiDAR on the top. But nevertheless, it's sufficient for the robot to walk indoor, outdoor. So this is a short video. So a master student did there the Autoware integration. And this is a video from our campus, so from our garage. And what he is doing, he's setting a goal position on the map of our campus. So you can see how the robot dog is localized. Then a goal is set and he's engaging the software stack. And then the robot dog is more or less walking like we would drive with our UGV or our vehicles out of the garage. So it's using the complete Autoware stack for localization, perception, control, and planning. The only difference is the interface to the platform. So this is in that case, no car. With this demonstrator, I would like to finish my presentation. I'm, of course, open for any kind of questions, and I also would like to say thank you to have the opportunity to show what we are doing with Autoware, and also a big thanks to the Autoware community, what you achieved over the last 10 years.
Thank you very much for the presentation, Marcus. Do you have any questions in the room or on Zoom? Well, I had a question for you. I thought the robot dog application was really interesting. It wasn't the first thing to cross my mind when you were thinking of Autoware, but it seems to work really well out of the box. Are there other applications like that which you're considering? Maybe like humanoid robots or other non-wheeled robots where you'd like to apply Autoware?
Yes, so this would be quite interesting, and we would really like to do this with a humanoid robot, because I think like the walking out of Autoware you could use quite well. Of course, then the manipulation with the hands, this is a different thing, but like walking on a campus or somewhere might be quite interesting, and we would definitely be open if let's say someone has a robot where we could try this out. This would be very nice, sure.
I mean, Unitree have the humanoid robot. Tesla's building Optimus.
Yeah.
Mobileye founders doing Menti. So who knows? We might have that at some point in the future.
I'm sure we will see one with Autoware running.
We also have a question from the chat. I can't actually read it from the angle. Can you see it?
Okay.
What is the heart of the robot dog inside as hardware? Do you mean like the battery? Or like the
No. Marcus, I would go to directly. So you saw the robot. What are the hardware using for this prototype? Is that inside? So I see that the box is that the NVIDIA thing, Orin, or what is that?
Yeah, so this is an NVIDIA Jetson Orin HX. Yeah.
So the question that is the kind of the general, is that how can I say, are you expecting to use another one hardware, or is it, well, it's the only for prototype, we don't care for the next level, we're just checking the algorithm, the rest we don't care, that's the industry. So how did the approach working on your side?
So in our case, this is the most time what we are doing. We are using the components where we are quite familiar, where we know, okay, we just deploy the software there and then it's running. But let's say if the Jetson AGX would be directly from the manufacturer in the Unitree Go one, then we also could deploy there our software there. And I think this might be possible with the Go 2. I think there's already an Jetson Orin integrated, but we didn't try that out.
Okay, I understand. Thank you.
Welcome.
Great. Thank you very much again, Marcus.
Thank you.
And our final speaker for the day is from Technocad, Matteo Barali.
Hello, good morning and good afternoon to everyone.
Great. Over to you, Matteo.
And I'm here today with Tianming that will help me on their presentation. And good afternoon to everyone. I'm Matteo Barale, Chief Innovation Officer at Technocad. And Technocad is an Italian company working from the last November deeply on Autoware. And really Autoware help and also build up our business. And Tianming, if you can share the first slide. Oh, just a few seconds, sorry.
Sorry, you see the screen?
Yes.
Okay.
And it's important for us to give you, as in the last presentations, to give you an outlook on how Europe is working on autonomous driving. And as an Italian company, we can say that Italy nowadays is a good niche and a paradise for autonomous driving companies, hardware and software both. And thanks to public grants and everything, we see a lot of vibration in the ecosystems, and we are trying to push outward adoption through our partners like universities and industries. And please, next slide. Technocad is a company that started its business in the 80s, so almost 40 years ago. Next year, Technocad is moving to be 40 years old, and is a global company with 500 people spread between Europe, China, and Brazil. And we are an engineering company. But 1 year and a half ago, when I come back in Italy and I joined the team, the company started to think about how move to the digital part. And thanks to collaboration, thanks to Autoware and thanks to the ecosystems of Autoware, so companies like Pixmoving, Well Dynamics, AutoTech. So we build up our ecosystem to move to the next generation of vehicles. Today, like also other people, I'm calling from Munich, from the VIA Mobility Summit. And here, basically, every company is talking about the next phase of automotive. And we can say that the next phase of automotive is not just autonomous, is, as we have seen in the last presentation, about robotization, automation, because autonomous, I think, is just the first step of full automation of the vehicles, or by way, everything that is moving from point A to point B. Next, please. And how we start our business, because this presentation is also to show to you how Autoware enable our business in this new era of automotive. So nowadays we have an ecosystem partners that we are building up. So one is Pixmoving, another one is AutoTech. So both companies working on robobus, robotaxis, and platforms, and then Well Dynamics, where we collaborate on the digital twin. So thanks to that, we are able to cover basically 360 degree of autonomous mobility, and from the last mile to bus applications. Next, please. And for us, Autoware is, and it was, a business enabler. So when we start 1 year ago with the first hire, that is Tianming, our tech lead, that is here in the call. We start our business to build vehicles, because Technocad is a company that is building vehicles from zero, from design to running vehicles. And we have seen that we were missing the digital part, so how we can automate the vehicles. And we've seen Autoware as the main starting point, and we start our business from there. And nowadays we are working on several aspects, but it's not just only about autonomous level 4, but is also about data management, digital twin. So we're using all the stack of the software, and we implement also a data storage here in-house that is helping also companies that are not from Europe to store their data and to manage their data, their local operations. And we are working a lot on 5G management and low latency issues that we see is the main topic nowadays of our business. And as in the previous presentations, we really love to spread more about the end-to-end, because we truly believe that the end-to-end will affect not only, as we have seen, not only automotive mobility field, but also all the robotics systems. Next, please. Where we are in Italy, as we said, as a headquarter, and we are able to develop a Tier 9 project. so from tier 3 to tier 9 running vehicles. And nowadays we have 10 people that are totally based on Autoware, so computer science guys. And this is important because usually automotive companies like us or service engineering companies, they have people in the technical, in the software part that are coming from EE architecture, from mechatronics, but not from computer science. So we decide to hire people in this sector. And nowadays we are one of the largest team in Italy. Then we have a vehicle laboratory with dynamics. We have this DTV that is possible to use to develop different vehicles. Robust demonstration with Pix and Alvatech. So we have a long-term partnership with them, and digital and physical testing. This one in the picture is our headquarters, and the front yard and the backyard nowadays is 1 kilometer of circuit where you can test not NCAP, not homologation testing, but traffic condition, weather conditions. So for us, it's important to test ODD, different ODD during the development. So we are able to make software envelope and hardware envelope here in-house. So open to talk about that, and also to share our digital twin also for development to the community. So as we said, we are working on engineering, development, and running on operations. These activities are independent or complementary. For us is almost the same, but the main focus of our team is to work on Autoware and develop applications close to the market, because customers from Technocad are coming from OEMs, traditional OEMs, like Italian ones or Germans, Chinese. But the customers of our team are not them, are totally different, are public companies, cities. And these companies, they are asking for running vehicles in real world applications. It's not just develop a vehicle, but they ask a full package. So for that reason, it's important to build not just a pipeline, but an ecosystem of partners to develop running vehicles and running demos. Here is our park, I can say. So where are our focus? We are working nowadays a lot on delivery and people mover, because the market is asking for that. We are in development of 5-6 vehicles here. And what is the next step? The next step for sure is all related to off-road, but it's not just agriculture as in the slide, but it could be also trains, trams, so everything that is not automotive grade, but is off highway. But is the main task, and is also a step closer to the robotization, because when we talk about agriculture, like huge Japanese companies, we are betting a lot on robotization, but it's no more a tractor, but is a robot on the field. So that is our next target, and also where we want to bring our expertise on end-to-end application of that. Next. As we said, it's important to talk also about customers. So when we develop application in the past, it was more for OEMs, tier 1 startups, is okay. But the main customers nowadays are coming from cities, governments, public entities, and it's important to teach them what is autonomous driving, to show to them a demo, because here in this AutowareCon, everybody is already step inside or on a vehicle, on an autonomous vehicle, but usually people from other companies, they're not coming from our field, so they didn't know anything about autonomous driving. It is important for them to test them. For that, we are inviting a lot of public companies in-house to have a demo, not just to showcase, but to have hands-on. And it's important to move step by step with them, also to talk with them about digital asset. That is a digital twin, but digital twin for public, for municipalities, usually it's just scanning a document, but is maximum digitalization. And it is important to teach them what is a HD map, what is a vector map. So what is all the step to develop a business, and then for sure develop a service, complete service with them. And here the first project that we had done in the company, it was AD1. In Italian we say Adone, but basically it was our first application that we had done in collaboration with Pixmoving, and it was based on a Pixmoving Robobus, where we completely digitalize our company, our headquarters, making the largest digital twin in Italy, open to test for our EV vehicles, but also for other customers or partners. And then we develop the full stack solution, because the cities, they ask completely a full package, not just one part. And for this reason, we develop with Pix all everything. And next, please. And here a short video about the first demo. And for us, it was also the first step to show how a vehicle inside a private area can be developed. And thanks to that, we show that industries or also huge plants, they can have these such applications, because when we talk about Europe nowadays, it's still about closed ODD, private ODD, and private roads, and also insurance. Nowadays they are comfortable with that. Next step for sure will be open roads, but the main market are in industries, universities, and big campus. This is our tourism. They are the main focus. Yeah, please next, Timmy. So the first step that we had done almost 1 year ago, it was in the tourism. This is an event that we had done in the city center during the Salone dell'Auto of Torino 2024, and it was crazy the effect on the people, because in Europe not everybody is aware about autonomous driving, but here in Torino, especially, I think in Germany and Italy, also like elderly people, they know really well what is autonomous driving, what is a robobus, what is a robotaxi. And when they approach this type of vehicles, they ask questions like, oh, this robotaxi, but I see in California or in China, whatever, it can be used by an app like Uber. And basically, you say always yes. So the expectation by people, every age, is ready for these kind of applications, and they know how to use it. So that is very important part. So the adoptance of the acceptance of this vehicle is really, this type of vehicles is really high. So the next step is not just make demo, but larger scale demonstration. And the first topic is a pedestrian area in European cities, starting from Torino, because it's our hometown. Next. Then we are partnering a lot with universities like Politecnico Torino, Milano, and Unimore, Modena, Reggio Emilia. We work with them for development, to develop vehicles, to develop software based on the Autoware, and we promote Autoware inside the universities. And for them is important also because they usually have huge campus, and they are willing to use these sort of vehicles to move people around. So is an important case for them. Specifically, here we are in Politecnico Torino, and they have a huge area, and we're willing to use a RoboBus application there. And here is our premises, so industrial plants. We are building a digital twin from next week. That is the largest digital twin, not in our premises, but nearby, for a huge market area, and that is the biggest market for this application. So you build a digital twin for them, then you build maybe robotaxi or robobus application, and then you enlarge it to last mile application and so on. So this is really an important playground for our industries. And here is the end so far. So this was a presentation to show to you an outlook on how does it work in Europe, what's happening in Italy. So that is happening really a lot, and people mover nowadays is still a good focus, okay, and also a good market. And next we'll have goods, last mile, and middle distance vehicles. That is a second one, and in future we are thinking about services of waste too. And so thanks to everybody. I hope you enjoy the conversation, and also thanks to Autoware, because really Autoware is the enabler of our business. Thanks.
Thank you very much for the presentation, Matteo. We have a question on, it's just a comment. So any questions in the audience? Well, I have a question for you, Matteo. You mentioned a number of use cases like tourism, closed geofence sites, and things like that. Which use case are you seeing the most traction with at the moment?
The most promising, you mean?
Yeah.
The most promising, I think, is in the industrial plants.
Mm-hmm.
That is the most promising, because usually they have really huge plants, and they want to move to industry 4.0 to 5.0 now. And the industry 5.0 is a lot about autonomous applications, and to make industry 4.0 concrete, and also not just indoor but also around the plant. And I think it could be our primary focus in a short term. When we talk about middle term, for sure, semi public in the cities. So when we talk about tourism in a pedestrian area or dedicated line, that is a medium term focus. Maybe not on robotaxi, or maybe more on robobus application. So on bus application, like maybe around 25 people. This kind of solution.
Very interesting. I wanted to mention that we have started a new work group within Autoware Foundation called the Low Speed Autonomy Working Group, and its focus area is to build TRL6, TRL7 Autoware stack designed for low speed industrial logistics, intralogistics. So I encourage you to attend that and contribute to that as well.
Thank you. Yes, we'll do it.
Thank you very much, Matteo.
And if you have any technical question, Tianming is here also to answer.
What was that, sorry?
So Tianming is also my tech lead. If you have any technical question about anything, he can answer too.
Great, thank you very much.
Thank you.
And now I'd like to pass over, if there's no other questions, I'd like to pass over to Samit to just share a few remarks.
Thank you, Zen. I just wanted to give my thanks to all the presenters and all the people who went to Nagoya University to celebrate basically Autoware's 10 year of existence. I think the AutowareCon turned out better than all of us expected. And I also want to give my special thanks to the Tier 4 team over there to accommodate all the needs for a conference. Thank you so much. And I also just want to mention this end-to-end driving report we just put online on the Autoware website. If you go to the Autoware website, it's a pop-up, and I've been seeing tons of downloads about this as well. I just want you to spend half a minute of your time to go to the Autoware Foundation's LinkedIn page and like that post and repost it, so it can go to wide and deep, as Zen mentioned several times. We want this major breakthrough in front of everybody, and surely we will continue arranging slots on podcasts, doing PRs, and a whole bunch of additional activities to get this in front of everybody in the automotive industry. Just want to say thank you, and greetings to all of you from IA Mobility. That's it. Thank you so much.
いいよ。お疲れ様でした、長い間。Long day, huh? So, once again, thank you very much for your active participation to AutowareCon, as well as day-to-day contributions to all kinds of Autoware-related activities. A few announcement from myself. First, to everyone, we will send out the feedback survey after the event. So please let us hear your voices for the next AutowareCon. And for those here in Nagoya, we will take a group photo, 記念撮影をします。So right after this, my final remarks, please come to the stage here, and we take photo. Then one more thing, social event. The dinner place or restaurant is in the campus, but it's 10 minutes walk from here. So we will move in a group. I and Joanna over there will navigate to the restaurant. So I give you 5 minutes to pack your stuff and clear your table. So what time is that? 6:25. We will leave here in a group. この後のソーシャルイベントの場所はトヨタ講堂っていう道路の反対側にありますので、ちょっとみんなで行きますので、6時25分ぐらいにちょっとまでに準備をしておいてください。じゃあ写真撮影を撮りますので、ちょっと皆さんこちらに集まってください。So to those online, thank you very much. We're going to cut the connection for now. Thank you very much and see you soon.